Welcome to the complete JavaScript course for 2025. In this course, you're going to learn everything you need to know to master JavaScript and start building real-world applications. Whether you're just getting started or looking to brush up your skills, this course is designed to take you step by step through all the fundamentals and advanced topics. Here is what you will learn inside of this course. We'll start by understanding what JavaScript is, its history, and how to set up development environment. We'll dive into the fundamental building blocks such as data types, operators, how to control the flow, how to execute loops in JavaScript, use functions, objects, and more. Then we'll learn about the document object model and how to interact with and manipulate the elements on a web page using JavaScript. After that, we'll move on to error handling and debugging. We'll understand how to handle errors and how to debug them in the console and also in the browser developer tools. And in the final sections, we are also going to learn about asynchronous JavaScript, things like how to manage time-consuming tasks like network requests or callbacks with promises, async await, and more. And the best part about this course is that throughout the course, you won't be just passively watching the videos, you'll be actively engaged with hands-on exercises and practical projects. That's the most effective way to truly understand and internalize these concepts. We'll be building 3 hands-on projects to apply what you're learning in this course: an online calculator, a quiz app, and a weather dashboard. By the end of this course, you'll not only understand the theory behind JavaScript, but also have the skills to build your own web projects. And a short note about myself: I'm Haik, a senior full-stack developer with over 7 years of experience with building real-world JavaScript applications. I've worked with over 10 companies and I delivered over 20 projects, and most of these projects were using JavaScript. And I'm looking forward to helping you become a confident JavaScript developer. By mastering the topics inside of this course, you'll be well on your way to becoming a front-end, back-end, or full-stack JavaScript developer. Let's start with the most obvious question, which is what JavaScript is and why you should consider learning it. JavaScript is one of the most popular programming languages out there. It dominates the web development by powering both client-side interactions in browsers and also server-side applications through Node.js. As you can see, according to the latest developer survey on Stack Overflow and also in the latest updates in Statista, JavaScript is the most widely used language among developers. And all of the major companies like Google, Meta, Netflix, and countless others rely on JavaScript to build their complex web applications. It is also the most demanded programming language according to this research of the last year, and this is based on job postings on major platforms like LinkedIn, Indeed, Glassdoor, and others. And you may notice it says JavaScript/TypeScript, which is just a superset of JavaScript. And this includes the front-end, back-end, and also full-stack developer roles. And you can choose your path and which one you prefer. But in total, JavaScript is the most demanded programming language by now. Now let's look at some salary statistics. The average JavaScript developer salary is above $100,000 per year, and this is based on US market. If you look at the Glassdoor, you can see that this is the typical range, and this is how much an average developer earns in US. Now if you are from Europe, this is the average JavaScript developer salary in Europe, which is again above 100,000 per year. And you can also look at the Web3, which are the remote developer jobs mostly. And here, as you can see, the base salary starts from 60K and the maximum can be 240K per year. Now obviously this number may be much higher if you're working for FANG companies. And this Glassdoor range is for US developers, but you can set your area here and see how much is that number for your specific area. But your location doesn't really matter nowadays, as most of the developer jobs are remote, and especially after COVID, companies don't really care about your location and most of the developer roles are remote. But still you can check this for your area and see how much is this number in your case. Now if you're convinced why you should learn JavaScript and you're sure you want to get started, let's understand why JavaScript was created in the first place. So to understand that, let's imagine how websites worked before it existed. When you visited a website on your browser, you would typically send a request to server which would return you the HTML and CSS files to create the visual layout. You can think of this as static pages with no interactivity beyond basic links. And then if you clicked on a button, let's say, or filled out a form, or wanted to see an updated content, this entire page would need to reload, leading to a slow, clunky user interface. And this means that you would need to make another request response cycle to get back the updated web page. And this constant back and forth communication with server was a bottleneck, so that's why JavaScript was introduced to make the web more dynamic and interactive. So instead of needing another round trip to the server for every action, we can use JavaScript, which allows us to update the content of the current web page directly within the browser. And this opens up new features for us, like having single page applications or smooth animations and instant validation of form inputs, or things like image sliders, interactive maps, and real-time updates without the need to do a full page refresh as we did it previously. Let's take a quick peek at how JavaScript works in the browser. You can open up any web page in your browser, whether it's Google Chrome, Safari, Microsoft Edge, or anything else, and here you can right-click and choose Inspect. And this will open up the developer tools. And the alternative to this is you can use the shortcut F12, and this will again open up that developer tools. Now, depending on your configuration, this might be on the right side of your browser or on the left side or at the bottom, or this can be an entire window separately. And you can see at the top we have a bunch of tabs, and we will go through these throughout this course. And the first tab that will open up here is the Elements tab. Here you can see your HTML file and also your CSS styles. But for now we are interested in the console tab, so let's go there. This console tab will be mainly used for accessing your JavaScript logs. Let's say you have a website or a web application that is running in the browser. Here you can see your error messages from the JavaScript or the logs that you put in. Let's say you are tracking some variables and so on. You can see all of that in this tab. But you can also write JavaScript directly in this tab, and that's what we will do now. For example, we can log a message in this console by typing console.log, and we need to open it with the opening parenthesis. And here we need to write the message that we want to be printed. Let's say hello JavaScript. And we need to close the double quote, and we also need to close the parenthesis. And this will log this message in the console. And we can also mark the end of this code line by using the semicolon and hit enter. And you can see our message gets printed in the console here. And if you don't understand the syntax for now, that's completely fine. We will go through this throughout this course. This is just to show you how JavaScript works in action in the browser. We can also create a small pop-up window in this web page by using the alert function of JavaScript. And we need to again open the opening parenthesis and pass the message. You can see it also helps us here. And to pass the message, we again open this with double quotes. And here we can write our alert message. Let's say alert message. And similar to the above command, we close this and we close the parenthesis and we mark the end of this code line and hit enter. And now you can see this small alert message, and we have our message inside of the body. And we can click on this button and close the alert. You can also do simple arithmetic operations here. For example, we can do 5 plus 3 and we will get the result here, which is 8. You can also store one of these numbers inside of a variable. We can declare a variable by using the let keyword, and then we need to define the name of this variable. Let's say x equals to 3 and enter. Now we can access that number that is stored inside of x by typing x and hitting enter, and you can see we have 3 stored inside of this x variable. And this means we can perform operations with this x also. We can do x plus 5, and this will be the same result as 8 because we have 3 stored inside of this x, so this converts to 3 plus 5, which is 8. And when this console log gets messy, you can always clear it by clicking on this button, and this will clear the console for you. We can store other variables as well, like we can store the name of a person here, and let's say this is John. And now we can use this variable inside of a console log message. Let's say we want to console.log. Let's say we want to say hello and the name of this person. We can say hello and close these double quotes and then plus the name of the variable that is stored there and enter. And this will print hello John in our console. And this was just a quick peek at how JavaScript works. And obviously we don't use this console to write our code. We do that in a development environment. This console tab is mainly used for checking error messages in your code or tracking variables and things like that. But we need a proper developer environment so that you can start writing code in JavaScript, and that's what we will do next. Now this browser console is just a playground for us to see how JavaScript works, but obviously this is not where real JavaScript applications are developed. For that we need to set up your development environment, and your first step is to download and install some code editor. I recommend Visual Studio Code. You can go to code.visualstudio.com and download Visual Studio for your operating system. And once it's downloaded, follow the on-screen instructions and install it on your machine. And after you have the VS Code installed, let's install two extensions that we will need throughout this course. You can go to the extensions tab here. Let's search for the first extension that we need to install, and it is called Live Server. If you search for a live server, you will see the first result is the extension that we need to install. This will let us launch a local development server directly from VS Code, and any changes that you make to your code will be automatically reflected in the browser without manual refreshes. And the second extension that we need to install is called Prettier. If you search for the Prettier, this will again be the first result in the extensions. Install this extension as well, and this will automatically format your code to make it consistent and easy to read. And lastly, if you'd like to have the exact same setup of VS Code as I do, meaning the extensions, the themes and colors, I'll leave a video below this lesson where I show you exactly how to set it up and how to install the extensions and everything that I have in my VS Code. So now let's close this extensions tab and let's go to the Explorer. Let's create a project folder on our desktop and let's just call this first project. Now drag and drop that project inside of VS Code and this will open that project folder here. In VS Code on the left panel, let's create a simple HTML file. Let's name this as index.html. Inside this file, let's generate a basic HTML template by typing exclamation mark and hitting enter. And this will generate a basic HTML skeleton for us. And here within the body tag of your HTML file, let's add some JavaScript code. We first need to enclose our JavaScript code inside of a script tag, which wraps the JavaScript code inside of it. And here we can basically write the exact same code that you saw in our browser console, but this time we can write it in our project code. This means we can use the same console.log, and here you'll notice when you open the parentheses, it automatically adds the closing one as well, and we need to also add the message inside of this. So we will open a double quote, and again you can see it marks the end of this double quote as well. So this simplifies the workflow for you. And here we can write any message that we want. We can write the same message that we had in our browser console. And in this case, we are telling the browser to display this message in the developer console. Now we can mark the end of this JavaScript statement by again adding this semicolon, but technically they are optional in most cases, and even if you forget to add a semicolon like this, it will automatically be added by the Prettier extension that we installed. And if you haven't configured this already, let me show you how it's done. You can click Command-Shift-P, and I believe this is Control-Shift-P on Windows. Here search for settings and choose this option here. And inside of settings, just search for settings again. And here click on edit in settings.json. Here you will find the configurations of your VS Code. And here anywhere you can pass this line and hit save. And what this does is this configures your default formatter to be the Prettier extension that we installed. As you can see, you can also configure it to specifically apply for TypeScript code or for JavaScript code or for JSON or anything you want. So you can specify specific scenarios where you want to format with Prettier. Or if you paste this line globally, this will mean that it will always use Prettier in HTML files, in CSS files, and anywhere in your code. So if you hit save here and go back to your index.html file, let's just remove this semicolon and hit save. You can see this was automatically added by Prettier and it also automatically formatted our code nicely. Now let's see if this code gets executed, and for that we will use the other extension that we installed. So right click on this index.html file and here you will see open with live server, and this is because of the live server extension that we installed. And if you click on it, this will bring you to this web page, and obviously this is empty for now because we haven't added any HTML code inside of the body. But you can right click and inspect developer tools here, and if we go to the console tab, you can see our message hello.js here inside of the console. We can also use the same variables that you saw in the browser console. For example, I can declare a variable here with let and say message equals to, and here you can store anything inside of this variable. Let's say this is our message variable, and below this I can use this message variable. For example, I can do console log and then the message that we stored inside of this variable. Now I will skip the semicolons here as well, and if I save this, it will automatically be added. And you can see that Prettier also changes the double quotes to single quotes, and this doesn't have any effect, so you can use the single quotes or also the double quotes, and you can also configure it in the settings.json. Here if you search for quote, and here you can see Prettier.single quote setting, and it is set to true. Now if we set this to false and save this, now if you save this file again, you can see it uses now the double quotes, and this is just a preference. You can set this to double or single quotes. In my case I just set this to true and it will use the single quotes. Now with that, if you just go back to the browser without refreshing it, you can see your message variable here, which is the other log that we put in there. And this is thanks to the live server extension that we just installed. You can also use comments in JavaScript. For example, if I want to add a comment here saying that this is a JavaScript comment, if I save this and go back to the console, you won't see that in the console and the browser will simply ignore it. So comments in JavaScript start with 2 forward slashes, and this indicates that this is a comment and it should be ignored by the browser. These are just human readable notes that we can put in place so that other developers can understand our code. And let's discuss one final thing in this lesson. The script tag that we added in our body, this is just a quick way for us to write JavaScript. But in real applications, we don't write JavaScript code inside of these script tags. As you might imagine, our HTML file might get a lot bigger than this, and if we add also the JavaScript here, it can get very messy and it will be very hard for us to read the code and understand it. And this is called separation of concerns, where we separate the JavaScript code inside of JavaScript files, we separate the HTML inside of HTML files, and we also separate our CSS inside of .css files instead of writing them in the HTML code. So to keep our code organized, we can copy this JavaScript code from here and create a file here called script.js, and we can paste it into this file, and we don't need to format this manually. You can just click Command S or Control S and this will save it. And then what we need to do is we need to go to the index.html file, and here we can get rid of this code, and we just need to link that JavaScript file here, and we'll link it by the source attribute on the script tag. So we pass a source attribute and we'll link this to the script.js file that we created and save it. And you can double check that this works by going to your browser, and you will see that both messages that we have in our code. And as you can see, we placed this inside of the body of this HTML file, and this is the most common place to put our script tag. If you add some HTML content here like h1 tag and then divs and anything, you would typically put this script tag at the end of the body tag. And this ensures that all your HTML content is loaded before JavaScript code runs, and this prevents issues where JavaScript might try to interact with elements that haven't appeared on the page yet. So that's the most typical place to locate your script file. Now obviously if you have some specific needs where some part of your JavaScript needs to happen before your HTML code, then you can change it and maybe split your files into 2 or more JavaScript files, and some of them might run before your content and some of them might run after your content, but this is just most typical place that you would need in your JavaScript. And with that, you have just set up your development environment and written your very first lines of JavaScript code. But in the next lesson, let's understand how JavaScript works and how our code is executed in the browser. Let's take a closer look at how JavaScript code gets executed. JavaScript was initially designed to run within web browsers, and each browser has a JavaScript engine. This engine is built into most major browsers. These are engines like V8 on Chrome, or JavaScript Core on Safari, SpiderMonkey on Mozilla, or Chakra on Microsoft Edge, and many other JavaScript engines that run within web browsers. And it's basically a software that lives within your web browser and it's responsible for executing our JavaScript code. Let's see how this actually works. So first you write your JavaScript code, and once the JavaScript file is received by the browser, the engine starts to compile your JavaScript code. But before compiling it, it first parses your JavaScript code. This means that it converts the source code into tokens, and tokens are just small units like keywords like let, const or function keywords, and operators, literals and identifiers. And then this JavaScript engine parses these tokens to create the abstract syntax tree. The next step is the compilation step. So modern JavaScript engines like V8 use a technique called just-in-time compilation. And this means that it compiles our JavaScript code into a machine code so that it can be executed. And after that, we get to the execution step. And this is when we will see the effects of our code in the browser. So in this step, the engine starts to interpret our JavaScript code, which is then executed by the JavaScript virtual machine. And once it is executed, we will see the effect on our web browser, which is like Google Chrome, Safari, Microsoft Edge, and any other major browsers. And once it is executed, it also goes through garbage collection step. Now we will learn what this actually means in the later sections of this course. For now, let's just understand what JavaScript engine does in this step. It periodically scans and cleans up the unused variables and unreachable memory. And in the last step, we have the event loop. This is again a bit advanced topic, so we will cover in the later sections. But basically, since JavaScript is single-threaded, meaning it cannot perform time-consuming operations synchronously, we have this event loop. And this event loop continuously checks the call stack and message queue for asynchronous operations that are finished. And it notifies the call stack so that our asynchronous code can be executed. Now let's see how JavaScript works in the browser in development mode. And development mode is basically when you develop it on your computer and this is not deployed anywhere, so you're trying this code in your machine. And that's why we call this development mode, meaning that we run it on our own computer and our files are not yet optimized for the production server. So first you write your code like HTML, CSS and JavaScript in your code editor, which can be VS Code or something else. Then you launch the live server extension or you just manually refresh every time you make changes. And this starts the local server on your computer. And then when you open the HTML file in the browser, it fetches the associated CSS and JavaScript files from your local live server. And once your browser receives the JavaScript file, this is when JavaScript engine comes in and it reads your JavaScript code, understands it, and then executes it, which then brings your web page to life. So this is how we typically work in development mode in our computer. Now let's see how this works in production. When your application is ready to go live, you'll optimize these HTML, CSS and JavaScript files and you'll deploy it to a web server. This is just a remote server that will hold your HTML, CSS, JavaScript files and it will serve this to the users. And let's say some user comes in and opens your web page. When they visit your website, their browser sends a request to your server and it receives the HTML file that has the content and then it fetches the associated CSS files and also the JavaScript files. And again, just like in development mode, when browser receives the JavaScript file, here is where JavaScript engine comes in and it starts to execute your code and it creates the interactive experience for the user. And now that we understand how JavaScript is executed in the browser, let's have a look at what you can build with JavaScript. As we saw, JavaScript was initially designed for browsers only, meaning it was only meant to run inside of the browsers. But then in 2009, Ryan Dahl took this JavaScript engine and he placed it inside of a C++ program. And by doing this, he introduced Node.js, which is a different runtime of JavaScript. So he basically took the V8 engine from Chrome and he embedded it inside of a C++ program. And now this allows us to run JavaScript anywhere outside of the browsers. We can now run JavaScript on servers or on desktop apps or any other environments outside of the browser. And this is what made JavaScript way more popular in other areas of development other than browsers. So obviously you can build front-end web apps with JavaScript and this is what it initially was designed for. But you can also build server-side applications or APIs or real-time applications like chat apps or command line tools with it. You can even build mobile apps with it by using frameworks like React Native, which allows you to use JavaScript to create cross-platform mobile apps and then distribute it to both iOS and Android phones. You can also build desktop apps with it. You can use tools like Electron, but you will still use HTML, CSS and JavaScript that you know from web development, and you can build desktop apps with it. You can use frameworks like Phaser, which offers advanced capabilities, and build browser-based games and run them inside of the browsers. So there are a lot of things that you can do with JavaScript, and once you know the basics of JavaScript, you can easily transition to building mobile apps or backend development or games or anything you could imagine. But in this course, we'll focus primarily on client-side JavaScript, which is JavaScript that runs within your web browser. And that's because runtimes like Node.js or frameworks like React Native are big topics in themselves, and they deserve dedicated courses separately. So in this course, we will focus on mastering the fundamentals of JavaScript, which is the most important part, and then you can easily transition in other areas if you want to. There is often some confusion surrounding the terms like JavaScript, ECMAScript, and also Java. So let's clarify this before moving on. JavaScript is the programming language itself. It is what you'll be writing in your code editor, and it provides the syntax, the rules, and the tools you use to create your programs. Now, on the other hand, Java is a completely separate programming language, and while the names might sound similar, Java and JavaScript have very little in common in terms of syntax. Java is a general-purpose language. Often it is used for building large-scale applications, while JavaScript is primarily used for web development and related technologies. And then we have ECMAScript, which is the official standard that defines the JavaScript language. You can think of it as the rule book that all JavaScript implementations try to follow. So it defines the core features of the language, like its syntax, data types, and built-in objects, and things like that. And ECMAScript has gone through big evolution since it was created. Firstly, it was created in 1997. This was the ES version 1, which only had the basic language constructs. After that, it received many updates like in 1998 or 1999 and then in 2009-2011. But the big and major update was in 2015 when ES6 was introduced. And ES6 introduced a lot of new features like arrow functions, classes, template literals, destructuring, and many other things. And after this, it again received many updates every year. And the latest one is 2023, which is the ES14. Here we received new features like new array methods and other minor features. So it had many updates since 1997, since it was created. But this doesn't mean that you need to know every ECMAScript update that was out there. In this course, we will learn all of the latest syntax. So everything you're learning here is the latest syntax that ECMAScript offers, and you don't need to go through the documentations and then search for the latest features. But if you are interested in the history and evolution of ECMAScript, I will link a useful resource below so that you can check them out. And let's recap this section and see what we have learned so far. In this first module, which is the introduction to JavaScript, we learned what JavaScript is and why it's so widely used in web development. We learned how JavaScript is executed in the browser by the help of JavaScript engine and how JavaScript engine works under the hood. We also had a look at the history and evolution of ECMAScript, and we addressed the common confusion between JavaScript, ECMAScript, and Java. We also set up your development environment with VS Code and settings and extensions so that you can start building JavaScript applications. And we learned about the basic syntax of JavaScript by writing code in the browser console and also in the VS Code in your first project. We learned how JavaScript works in the browser and beyond with the help of Node.js runtime and other frameworks like React Native and so on. So that's it for this first module, and in the next lesson we will start learning about JavaScript building blocks, which will help us in writing JavaScript code and building applications. Welcome to the second section of this course where we will learn about the JavaScript building blocks. In this second section we will dive into the fundamental syntax and features of JavaScript, which will help us to build interactive web applications. In this first part of this module we will learn about the variables and constants. You'll learn how to store data in variables and how to work with different kinds of data. Then we will learn about the primitive data types in JavaScript, which are numbers, strings, booleans, and so on. We will use operators in our code, which are arithmetic, comparison, logical, and assignment operators to perform calculations and comparisons in our code. Then we will learn how to use conditionals in our code to control the flow of our applications with if-else statements or switch statements and so on. And lastly, in the first part of this module, we will learn about functions, and we will use functions to create reusable blocks of code. And while working with functions, we will learn how to declare a function, how to use function expressions, and how to pass arguments to it, and how to use the return values from functions. And we will learn all of this in a practical way, so not by just hearing me talk about them, but by actually building this online calculator in our browser. This will be a simple calculator where in this first input you can input a number like 2, and then in this second selector you can choose the operation that you want to perform, let's say plus, and then the second number, which can be like 3. And if you hit calculate, this will calculate and show you the result in this paragraph. And you can also change the operator from here. Let's say you want to do a division and you change this first number to 6, and you can hit calculate again, and this will show you the result in this result paragraph. And below this video you will find this zip file attached to it, which is the boilerplate code that we are going to start with. You will need to download and unzip it on your desktop or somewhere in your system, and then drag and drop this into your Visual Studio Code. So this is a very simple project with just one HTML file and one CSS file. This CSS file just contains the stylings of this web page, and you can ignore the structure of it. What we are interested in is the index.html, which contains the inputs and selectors of our calculator. If you right click on this and choose Open with Live Server, you will see our calculator on your screen. But for now it is not functional. Let's say if I want to do 2 plus 2 and calculate, you will see that we don't have any interactivity on this web page. And that's what we will need JavaScript for, to add interactivity and the logic of this calculator. Now going back to our index.html, you can see the first input here, which is the first number that we included there. Then we have this selector which chooses the operator like plus, minus, multiplication or division. And in the second input we include the second number of our calculator. And then we have this button, which is the calculate button that you saw on our screen. And once the user hits on this calculate button, we want to do the calculation and then include the result inside of this paragraph tag here. So from the next lesson, we will start building this calculator logic step by step, and we will start from the next lesson where we will also learn about JavaScript variables. To make this calculator interactive, we first need to start by storing some data, like the data in these numbers or the operator and so on. And this is where we will need variables to store all of this data. Let's go back to our project and create our first JavaScript file in this project. Let's name that as script.js. To declare a variable in JavaScript, we use the let keyword, and in fact we already saw JavaScript variables in the previous module of this course, but we didn't explore it in detail. We can use this let keyword and then assign a name to our variable. Let's name our variable as number, and for now let's just console log that variable and see what we have inside of it. If we save this file and go back to our calculator, we need to open the browser developer tools to see this in the console, and we do that by right clicking and choosing inspect. And from here let's go to the console tab. As you can see, it is empty for now and we don't see our console log here. And that is because we didn't link this script.js in our index.html file. As you saw in the previous lesson, we need to link that at the end of our body tag. So right after the last div, we need to add a script tag here. And here with the source attribute, we need to link to our JavaScript file, and that is the script.js file. And if we save this file now, if we go to the browser, you can see the value of that variable and it is undefined for now. This means that if we just declare the variable like this and we don't assign anything to it, it will be undefined by default. But we can also assign a value to these variables. Let's say we declare another variable and let's call this x. And to assign a value to this, we add the equal sign on the right side of that variable. And here we can assign a value to that variable, which can be 10 for example. And now we can console.log the x variable below the number and save this. And if we go back, you can see our first variable holds the undefined value and the second variable holds the 10 value. And these variable values are not fixed, we can always change them later. For example, now I can assign x to be 5 and hit save. And if we have a look in our browser, you can see the latest value of x is 5, not 10. So that is what we have logged in this console. And this knowledge is already enough for us to start thinking about the variables that we will need in our calculator. Let's go back to our calculator and here let's think about which variables we will need in our code. If you want, you can pause this video now and think about the variables and the names of them that we will use in our calculator. And if not, let's think through this together. As you can see, we have a first number here, which will be assigned to a value, let's say 2. And then we can choose the operator from this selector, which can be plus, minus, multiply, and so on. And then we have the second number, which will be assigned in this second input. And we will also need the fourth value, where we will store the result of this calculation. Let's say this is 2 plus 3, so we will need to store this result somewhere, and for that we will need another variable, and it will also be displayed in this result paragraph here. So going back to our code, we can now declare these variables. The first one will be the first number that is included in the first input. Let's call this number 1. And similar to this, we will have num2, which is the second value in the second input. Then we will need to somehow get the operator from our screen, and that will be called operator. And the last one will hold the result of this calculation, which can be like number 1 plus number 2 or anything else. And for that, let's declare another variable and let's call it result. We can also console.log these variables to see if they are defined or not. We can log the number 1, number 2, the operator, and also the result and save this file. And as you can see, for now we have 4 undefined values, so these are not holding any data yet, and we will be adding this soon in the code. But before doing that, let's practice what we just learned by doing a small exercise here. Our exercise will be to swap two variables together. Here I will give you two variables. Let's call the first one x and let's assign the value to this to be 2. And we will have the second variable which will be y, and let's assign another value to this y variable and let's say it is 4. Now what you need to do in this exercise, when we console.log these x and y variables, for now we will see 2 and 4 in the console, meaning that x equals to 2 and y equals to 4. But at the final result we want this to be 4 too, meaning that x equals to 4 and y equals to 2, and basically meaning that we swap these variables together. If we save and look at the console for now, we have 2 and 4, and that is what you need to do in this exercise. So go ahead and try this on your own for 10 to 20 minutes and then come back for the solution. Let's solve this exercise together. Now your first thought might be that you can just do x equals to y and this will swap the variables. But what this means is that we are assigning x to y and y holds the 4 variable. So if we do this, this will mean that we will have 4 stored inside of the x, but this same 4 will be also stored inside of the y variable. If you save and have a look, you can see we have 2 4s in the console. And you might think that we can do y equals to x and this will also store the 2 inside of the y variable. But actually we can't do this at this point because we already lost the value that was stored inside of x. Now we also have 4 stored inside of x, so this will just result y equals to 4, and that will be the same result in our console. That's why to solve this exercise we need some third variable that will hold the temporary value of x, and then we can assign x to y and then we can swap them together. And for that we will declare a third variable here. Let's call this temp, which will be temporary value of x. And now before doing this operation where we assign x to y, we will do another operation and we will store the x value inside of our temporary variable. This means that our temporary variable will hold the 2 inside of that. And after this we can assign x to y, so now we lost the value inside of x, but we still stored that in the temporary variable. And that means that we can assign the y to be our temporary variable, which holds 2 inside of that. And this should mean that we have stored 4 inside of x and 2 inside of the y variable, and we will see this in the console. If we save this and go to our console, you can see that now we have 4 and 2 stored inside of these variables. And if you were able to solve this, then congrats, and if not, don't worry too much, because this will make more sense as we go throughout this course, and this will just become second nature for you by the end of this course. And that's it for this exercise. I will clear this for now, and let's move on to the next lesson where we will learn about how to name these variables and about the best practices that we use when declaring variables. Let's dive into some best practices for naming variables in JavaScript, because choosing good variable names is very important for writing clean and also understandable code for others. And when declaring variables, there are some variable namings that are allowed and also considered to be best practices. And on the other hand, we have some variable names that are either not allowed to use or they are not recommended, meaning that they are not considered to be best practices. And the first example is that we can declare variables by using the let and then assigning name to this variable. Let's say this can be user. But we can also declare this same variable by using the var keyword, but actually this is not considered to be a best practice. We used var before ES6, which is a major upgrade in JavaScript, and we used this keyword to declare variables. However, declaring variables with var keyword can result in a very strange behavior, and it also had some limitations that made it less than ideal. And in modern JavaScript, we usually declare variables with let keyword, and we try to avoid using the var keyword at all. The second example is that say we have a variable that contains two words. Let's say it's called first name. You can just write first name together like this, but this is not very readable at the first glance, and we might not understand that this is two words together. We can separate them, for example, by using underscore between two names, and this will be better than using them together. But in JavaScript, we don't use these underscore namings, which is called snake case. We use the camel case naming for that. So a better way to define that will be to define it like first name by using the camel case notation, meaning the first letter of the second word should start with uppercase. And this makes it both easier to read for us, and it's also a best practice compared to using snake case like this. Another rule is that you should choose meaningful names that clearly describe what the variable is about. For example, if you just declare a variable to be named a, this is not clear at all about what this a variable holds inside of it, and instead you should choose a descriptive name for that. Let's say you are storing the result of some calculation inside of that a. It's better to name that as result at least, instead of calling that as a. Another rule that is set by JavaScript is you cannot start your variables with numbers. For example, if you want to declare the first name of second person, you cannot say to first name. As you can see, we are also getting an error by defining it like this. But if we come back to our third rule, why would you even want to define a variable that starts with a number? That is not descriptive at all. It's better to name it at least as first name 2 and add that 2 at the end of the variable instead of the beginning of that variable. Another rule by JavaScript is that you should avoid using JavaScript's reserved keywords. For example, let is a reserved keyword in JavaScript, and whenever JavaScript engine sees this let keyword, it knows that the following part after that is the name of a variable. And you cannot use that same let keyword to define the name of a variable. As you can see, we are getting an error, which is let is not allowed to be used as a name because it is a reserved keyword by JavaScript. Let's say you want to declare two variables at the same time. Let's say the name of a person and also age of that person. Here in front of the name you can assign a value to that name variable, and in front of the age you can assign a value to the age variable. But in modern JavaScript this is again not considered as a best practice, and instead it's better to define them separately by using the semicolon and separating them from each other like this. You saw that we cannot use the keywords inside of JavaScript to define the names, and there is another thing which is not allowed, and that is to use special characters. Let's say we want to define this first name, but instead of the underscore we want to use this dash like this, and this is again not allowed by JavaScript because you can only use the letters and digits when defining your JavaScript variables. Another bad practice in JavaScript is to define variables by starting with uppercase. This might be a good practice in other programming languages, but in JavaScript we usually define the variables by starting with lowercase like this. And lastly, except the let and var keywords in JavaScript, we also have const for declaring variables, where you can store constant values. If you truly want to define a variable that will never change, let's say a mathematical constant like this, you don't want this variable to be ever assigned to another value like 4, and by assigning it with const you can see that we are getting an error in the next line as we cannot redeclare the variables that are declared with const. So if you have a value that will never change throughout your program, you should use const keyword instead of let. And a good rule of thumb is to use const by default and only switch to let if you know you'll need to reassign the variable that you have. And now let's revisit the variables that we declared for our calculator, and let's apply these rules that we just learned. This can be another small exercise for you. Let's think about which of these variables might be better named using our descriptive names that we just learned, and also think about which of these variables could be declared as constants, because their values won't be changed by us after they are set initially. You can again pause this video and think about this and apply it to our variables, and then come back to the solution. Now let's try to apply the best practices to our variables. First, let's think about which of these variables might be better named. For example, you can see we have num2 for the first input in our calculator. Now that is somewhat descriptive, but this can be improved further. For example, we can rename this to be first number, and this will clearly indicate that this is the first number in the input that we have in the calculator. Or at least we can use number 1 and not shorten it like this, and this will be better readable for us. But in this case I will go with first number variable name, and following the same principle we can rename this to be second number instead of num2. Now our operator and result are descriptive enough. If you want, you can rename this result to be maybe calculation result. But since we are writing a program in context of calculator, we know that result is the result of the calculation, so we don't need to rename this. And that's it for the first question. Now in terms of the second question, which is which of these variables could be declared as constant, meaning which of these variables won't be changed throughout our program. For example, let's think about the first number. When the user gives us the first number, let's say this is 2, do we want to change this at all in our program once they give us the input? Now obviously not, because these are defined by the users and we won't be changing these numbers, we will just be doing calculations, and that means that we can declare this first number as a constant instead of as a variable. And the same applies to the second input. Once we get the second input number from the user, we don't want to change it at all in our program, so we will define it with const. And similar to that, the operator is also something that is coming from the user input. So we will declare it as constant and we won't be changing these variables throughout our program. Now the one thing that will be changing is the result, because this will be calculated by us throughout this program. Initially we will define this as undefined value as we saw in the console, but later we will do the calculation based on these numbers and the operators, and we will need to change the result and store the actual result of the calculation inside of this variable. And that answers to the second question here. And now if you hover on one of these variables, you can see we are getting an error, which is const declarations must be initialized. And unlike let, where you can just declare a variable without assigning a value to it, the const variables need to be initialized first. And since we don't have the inputs from user yet, let's just store some initial values like 2 for the first number and 4 for the second number. And let's assign the initial value to the operator. Let's set it to be addition. And with that we will get rid of these errors. But obviously we want to get these numbers from the user and not set it hard-coded like this in our program. And for that, let's move on to the next lesson and let's get these numbers and the operator from the user input. Now we need a way to reference those input elements in our JavaScript code, and to do that we will use this document.getElementById method, and this method will search for elements in our index.html file by their IDs. For example, if we want to grab this input element, which is our first number here, we can select it by its ID, which is set to first number. So if we copy this ID from here and go to our script, we can pass it inside of the brackets of this method as the ID of this element, and this will select that first number from our screen. This will only select it, but we also need to store the value of this somewhere, and for that we will declare a new variable. We will name this as first number input, and we will assign it to whatever is returned by this method. And this document getElementById is a DOM selector, and we will come back to DOM selectors in more detail in the later section of this course. But for now, all you need to know is that this method will select a specific element from our HTML file from here, and that specific element will be determined by this ID that we pass here. So if we pass first number, it will select this input. If we pass operator, it will select this selector. Or if we pass the second number, then it will select this input, and so on. And let's verify that by logging this in the console. So we will console log this first number input and save this. And now let's open our console here. And you can see in our console we have this input, which is this first number input that we selected from our screen. And that means that we also have access to the value that will be written here. For example, if you write a number here, we will be able to select it in this first number input. And we can extract that number by accessing the .value property on this first input element. And this will return us that free number that is stored inside of this input. And now instead of hard coding this number to be equal to 2, we can assign it to whatever the value is inside of this input. But we can't assign it like this. If I try to do first number input .value here and save it, you can see that we are getting an error in our console saying that it can't access this first number input before initializing it. And that's because we initialize it on the line number 6, but we try to access it on the line number 1, and that's why it won't work this way. And that means that we need to move this initialization before this first number element. And now if we log the first number here, this way it should work, and you can see we don't have any errors here, and it is also empty because the first number doesn't have any value at the moment. So this way we assign the first number to whatever is stored inside of this input instead of hard coding it in our JavaScript file. And now we just need to do the same for the second number input and also for the operator. So let's duplicate this line and we will rename this to be second number input. We also need to change the ID here, and to determine what the ID should be, let's go back to our index.html. And here you can see that our second input is named second number, so we will copy this and paste it inside of the getElementById method. And here instead of assigning it to 4, we will assign it to second number input.value. And let's duplicate it one more time, and this will be our operator. We can rename this to be operator select input. And let's also find out what the ID is of this selector, and it is set to operator. So we will copy this and paste it inside of these quotes. And here instead of hardcoding operator, we will use the operator select input.value. To be able to perform operations with our input numbers, we need to understand functions in JavaScript. Functions are one of the most important concepts in JavaScript, and they are what make our programs work behind the scenes. First, let's define what are functions. Firstly, functions are reusable blocks of code that perform a specific task or they calculate a specific value. They also help us organize our code and make it easier to read and understand for other developers. And an easy way to think about functions is they are just mini programs or functions that run within your larger program. And lastly, functions in JavaScript can be either built-in, meaning they are coming from JavaScript itself, or custom, meaning they are defined by us. For example, we already used built-in functions, but we haven't written any custom functions yet. The built-in function example is this getElementById. This is a function that comes built-in into the document object. We also used another function here, which is this log function, and this is built-in into the console itself. So we already used these built-in functions and we will use more throughout this course. But now let's also understand custom functions because we will need to define a custom function to perform the operation here. We define functions in JavaScript by starting with function keyword, and then this is followed by the name of the function. Then we open the braces and we also open and close the curly braces. This is where you will write the logic of what your function will do. And then also inside of these braces we can optionally pass arguments to this function. For example, we can pass argument 1 and argument 2 to this function, and then we can use these arguments inside of this body. For now, let's just do a simple console log and let's indicate that this is coming from function body and save this. And now to use this function, we have to call it somewhere in our code. And to call a function, you write its name followed by the parentheses. And here you can pass the arguments, but let's ignore them for now and save this. You can see in our console we are getting this function body log, which is coming from our function. Now you can see that using name is deprecated, and in general we try to keep function names also descriptive, similar to variable names. Functions in general can be divided into two types. The first type are functions that perform a specific task or calculation. These type of functions might change something on the screen here, or send a request to the server, or interact with user in some way. And the second type are functions that calculate and return some value. These type of functions take some input like these arguments here and they process it and then they return a result of this calculation. Let's see both of them in action. So the first type will be a function that performs a specific task. Let's say we have a function that greets the new users. Here we can pass the username as argument, and now inside of the body we can console.log. We can greet the user and then also add their username in front of this. Now we can call this by calling the name of the function and passing some argument, which will be the name or username of this user. And now you can see that we are getting hello John printed in our console. And the second type is a function that returns a result. For example, we can have a function that adds two numbers together, the A number and B number. And inside of this function, we can perform an operation A plus B. And instead of logging this, we can just return whatever is the result of A plus B. And in this case, we will call the add function and pass two numbers to it. The first one will be 2, and let's say the second one is 3, and save this. In this case, since we are not logging anything in the console, you won't see the number here, but if we put this inside of console.log, now you can see the 5 logged in our console. Now we need one function that will perform this calculation and it will change the result that is printed here. And you can maybe pause the video and think which function we are going to use, the first type or the second type. You might think that we are going to use a function that returns a result and calculates something, but actually we are going to use the first type of function because we don't want to return anything from this function. Instead, we want to alter the result that we have in this paragraph. So we will define a function and we'll call it calculate because this is going to calculate the result of our operation. For now, let's say our calculate function only adds the first and second numbers together and it ignores the operator. And in that case, we will define a result variable and this will be equal to first number plus the second number. And then we can console.log the result for now. And remember that after defining this won't be called by default. We need to call it somewhere in our code. And for that, let's remove this console log and let's invoke our function by calling this calculate method. For now, you can see that it is empty, and if I try to add two numbers together, we won't get anything in our console. And that's because we already called this function even before initializing these numbers and clicking calculate. But in our case, we want to call this at a specific point, and that point will be when we write these two numbers and then we click on this calculate button. For that, first we need to select the calculate button here. Let's go back to our index.html. As you can see, the calculate button has an ID of calculate. We can copy this and then we can duplicate one of these lines. Let's rename this to be calculate button. And we will select it by its ID, which is calculate. Now that we have the calculate button, we can call this function right when the calculate button is clicked, and we do that by using another built-in method in JavaScript. And we can call that method by accessing the calculate button, and then here is the method which is called add event listener. And this built-in method takes two arguments. The first argument is the event, meaning is it a mouse event or input event. So in our case, this will be just a simple click whenever we click on this button. And the second argument is actually the function that will be called whenever this button is clicked, and that function should be our calculate function. As you can see, in this case, we don't call it immediately, we don't pass these brackets, but instead we pass the function and it will call it whenever is the right time, and meaning whenever we click on this button here. With that, let's get rid of this first function call and let's save this. And now we can write numbers here in these inputs, for example 2 plus 3, and hit calculate. You can see that the result is empty for now. And that's another important thing to understand, is that we get this input value right at the beginning of this program. And as you can see, at the beginning of this program, it is empty. We don't have any value here. So instead, we need to get the values of these inputs inside of our calculate function, meaning right when we clicked on this button. And by that point, we will have the up-to-date values inside of the first number and also the second number inputs. Now if we save, this should work. If we go back and type 2 plus 3 and hit calculate, you can see that we got something in our console, but this is obviously not what you expected to get. You expected to have 5 here, and that's because JavaScript first thinks that these are text and not numbers, and it just adds them together side by side. In order for this calculation to work, we need to convert these to numbers, and that is where we need to understand data types in JavaScript, and let's discuss that in the next lesson. Let's fix this issue that we get in the console when we try to add 2 to 3 and we get 23 in the console. In JavaScript, like in any other programming languages, we have different data types and they are usually divided into primitive or non-primitive data types. For now, we only need to understand primitive data types. The first primitive data type is strings. These are just sequences of characters like hello that we typed in the first function, or like 1, 2, 3, but in a string format. And even though this looks like a number, it is still a string. And that's exactly what the issue here is. If we try to add 2 string to 3, it will just merge them together, and you can see in the result we are getting 23 instead of 5. And to be able to make this work, we need the other primitive types, which are numbers. And all of the numeric types in JavaScript are treated as numbers. For example, 1, 2, 3 without these quotes is the number 123. And decimals are also considered as numbers, like 3.6 and so on. And besides this, we also have booleans, and booleans are just logical values which can be either true or they can be false. We also have this special undefined type that is specific to JavaScript. As we already saw, if you just define a variable and not assign a value to it, this variable will be undefined first until you assign a value to it. And the last primitive type in JavaScript is null, which just represents that there is an absence of value inside of this variable. So the difference between undefined and null is undefined is when you declare the variable but you didn't assign value to it. But null on the other hand just indicates that there is no value inside of this variable. And these data types can be converted one into other. For example, we can convert the string 123 into the number 123, or we can convert 3.6 into string and it will be string 3.6 and so on. Now that we understand this, we will be able to fix our issue here. And just to double check, JavaScript provides us an operator which is called typeOf, which indicates the type of a variable. For example, we can determine the type of the first number like this, and we can put this into a console.log so that we can see it on our screen. And now if we try to add 5 to 5, for example, and hit calculate, you can see that the value of this was string actually and not number, and that's why we are seeing 55 here instead of 10. And we can convert the value of the first input into a number instead of string by using another built-in method in JavaScript, and that is called parseFloat. And this takes one argument, which is that string, and it will take this string and it will convert it to a number. If we save it and try again, let's do 5 plus 5 again and calculate. You can see that now it was converted to a number, and now we can use that parseFloat built-in function and we can wrap the value inside of it. We can do parseFloat and then pass the value of the first input, and we will do the same for the second input. And with these changes, when we try to calculate the result, meaning do first number plus second number, we are actually adding numbers together instead of string. Let's verify that this works. I will do 2 plus 3 here and hit calculate. You can see that the result is 5, or we can do like 4 plus 5 and you can see it's 9. So it's not merging them together as strings, but instead it treats them as numbers and it calculates the sum of these two numbers. And one last thing that we can do to improve the user experience is obviously users won't come into this online calculator and hit calculate and then open the console to check the logs. So we need to show the result here instead of showing it in the console. And to do that, first we need to select this paragraph from our index.html file. Here, as we can see, the ID of this paragraph is set to result. We will copy this result and let's select it below this calculate button. Let's rename this to be result paragraph, and we need to change the ID to be selected by this result ID. And here, instead of console logging the result, we will push this result inside of this paragraph, and we will do that by doing result paragraph.textContent, which is another attribute that exists on paragraphs. And here we can show the result by first writing result text in front of it and then adding the result, which is whatever the output of first plus second number is. If we save this and now try it again, 2 plus 2 and hit calculate, you can see that we are getting result. And one more important concept that we can understand from this calculation is that JavaScript is dynamically typed. What this means is when we try to add string to a number, you can see we are not getting an error. Instead, it is converted to a string and it just merges this string and number together. In other languages, for example in Java, you would get an error if you try to do this, but JavaScript allows this syntax. And this also means that, for example, if we declare a variable and assign number to it, and later we want to change this variable, and instead of storing number inside of it, we want to store a string. This will also be perfectly fine with JavaScript. If we console.log the result of x, you can see that we are getting text in the console and we are not getting any errors. And that's why in JavaScript we need to pay attention to our data types. And especially when performing calculations like this, because we might get some unexpected results as it doesn't prevent us from getting these errors. In our last lesson, we set up this calculate function, which currently calculates the addition of these first and second inputs here. For example, if I input 3 plus 2 here and hit calculate, we will see the result in this result paragraph. But as you can see, our code here doesn't really care about this selector. For example, if I select 3 minus 2 and hit calculate, we still get this 5 result here. And that's because we only do addition here and we don't use this operator, which we selected from the HTML document. And this is where we will need to learn about JavaScript operators and also JavaScript conditionals so that we can use these techniques to perform our calculation based on this selector here. Let's start with operators, and actually we already used operators. We used this plus operator which adds these first and second numbers together. And we have all the similar operators that you have in the math. For example, if I declare the result here, and let's reassign the result variable below it. This first one is the addition operator. We can also duplicate this line and do subtraction instead of addition. And in this case, we will do first number minus second number. If I save this and let's try it in this calculator. If I do 3 minus 2, and don't get confused by this plus icon here because we don't use it yet. So this basically means 3 minus 2, and if I hit calculate, we will get 1 in the result. We also have the multiplication operator. We can multiply first and second numbers. If I do 3 times 2, we will get 6 in the result here. And lastly, in the simple operators, we also have the division. If we want to divide the first number by the second number, we can do division operator. And here, if I do 3 divided by 2 and hit calculate, we will get 1.5 in the result. And these operators that you saw here are called arithmetic operators. So now we can perform all of the types of calculations that we have in our selector. But how do we make a decision which calculation to use? For that, we first need to learn about another operator type, and that is the comparison operators. And before using the comparison operator, let's just console log the operator that we stored inside of this variable. And let's see what we have stored inside of this operator when we perform the calculation. If you open the console log here, the first case is when we set it to addition and we hit calculate. You can see we get the addition operator in the console. And similarly, if we choose this to be subtraction and hit calculate, we get the subtraction here. And all of the other operators should work the same way. So if we select the multiplication, you can see that in the console. And similarly, we can have the division and hit calculate, and then we will have the division in the console. And the comparison operators help us to identify what is stored inside of this variable and check whether the value equals to division or plus or minus or anything else. And the most common comparison operator, which we will also use here in this case, is the free strict equality. For example, with this operator, we can check whether the operator equals to plus and save this. And the value of this should be either true or false. For example, if I select minus and hit calculate, you can see the value is false because this operator is equal to minus and not plus. And now if I select plus and hit calculate, we will get true in the console. And now we will use this comparison operator in combination with conditionals in JavaScript to perform these operations based on the condition that we will set. And the most common conditional in JavaScript are if-else statements. So we start the statement with if keyword and then we open the braces. And inside of these braces will be the condition based on which we perform our calculation. And then similar to functions, we open the curly braces. And inside of these curly braces, we will have the code that will be executed in case this condition is true. And now we can use this same condition but inside of our if statement, and we can get rid of this part here. And now what this code means is that whenever operator equals to plus sign, we need to perform some calculation, and that calculation will be to add these first and second numbers together. So that means that we can move this part of code inside of this if statement and save this file. But this is just one of the cases that we can have in this selector. As you can see, similarly, we can have minus or multiplication or division. And for that in JavaScript, we can continue this if statement and we can do else if and open the braces and also the curly braces here. And what this basically means is that if this first condition is not true, meaning the selected operator is not plus, then we can check for another condition. And let's say in this case, the operator equals to minus and not plus. If this condition is true, then we need to calculate subtraction instead of addition. So we will copy this code and paste it here. And now we can just continue this chain. You can have as many else if statements as you want. So we can have another else if statement for the multiplication, and then we can have another one for the division. And at this point, you can pause the video and try to write the rest of the code yourself. And if not, let's continue from here. We need to open the brackets for the other condition, and that other condition will be whenever the operator equals to multiplication. That is when we select the multiplication here in the selector. And in this case, we need to do the other calculation, which is to multiply the first and second numbers. And our last condition will be if the operator equals to division. And in that case, we need to divide the first number by the second number here. And if we save this so that it's formatted by prettier, let's go through the logic one more time. If the operator equals to plus, then we add the first and second numbers together. If the operator equals to minus, then we subtract the second number from the first number. If the operator equals to multiplication, then we multiply the first and second numbers. And then if it equals to division, then we divide the first number by the second number. And now we can save this and try our code here. We can close the console and let's do first number 4 plus 2 and calculate. The result will be 6. But now let's change this selector and let's set it to be minus. So this will be 4 minus 2. If we hit calculate, you can see it equals to 2 now. So what happens in our code is we get this operator from the HTML document. And then we check if the operator equals to plus, and since it is not equal to plus in this case, then we don't execute this code. Then we move to the next line, which checks if the operator equals to subtraction, and this comparison results in true because our operator is set to subtraction here. And here we set the result to be first number minus second number, and then we display the result at the end here. And we can check for all of the other operators. If I set this to be multiplication, then this will equal to 8. And if I set this to division, then this will equal to 2. And one other thing we can add to our conditionals is the last case. And that is if the operator wasn't equal to any of these values. In that case, we can enter another block of code and we define that by the else keyword in JavaScript. And we again add the brackets here to execute this code. And as you can see, we don't have any conditions here. For the else if statements, we have the operator should be equal to division or multiplication. But in case of the else statement, we don't have any conditional. And this means that if none of the above statements were true, then we enter this piece of code. And for instance, here we can set the result value to be invalid operator. And we can get rid of these comments here and save our file. Now, since our HTML document is written properly, we won't get this error of invalid operator because the operator equals to one of these fours and we have the conditions here. But for example, if we go to the index.html and let's add another option, and here if we change the value of this to be completely random thing and also the value here and save this. Now if we go to our calculator and let's try to do 3 and 3 here and let's select that last option here and hit calculate. You can see that we get the result invalid operator because this is not a valid operator and we were expecting one of these operations here to be performed, and if none of these were true, then we enter this last state, which is the invalid operator. Now obviously we won't pass something like this from our HTML file, but in any case it's good to have this last else statement, which is the default behavior, and even if the HTML file is written incorrectly, this will handle that case and we won't get any errors in our screen. In the last lesson, we covered the essential arithmetic and comparison operators that are needed for our calculate function to perform the calculation. But now let's expand our toolkit with some more advanced operators, and we will actually use some of them in our calculator function. Let's start with the arithmetic operators. We already used the basic arithmetic operators like plus, minus, multiplication, division, but there are more arithmetic operators than these. For example, we have the modulo operator, which is the percentage sign, and this operator basically gives you the remainder after the division. For example, if we do 10 modulo 3, we will get 1. Since 10 equals to 3 times 3 plus 1, this 1 is the remainder after the division, and that is why we get 1 here in the console. For example, if we do 10 modulo 2, we should get 0 in the console. And that is because 10 equals to 2 times 5 plus 0. And this 0 is the remainder that we get in the console. The next arithmetic operator is the exponential, which is two multiplication icons together. For example, if we want to calculate the 2 powered by 2, which equals to 2 times 2, we can use this exponential operator, or if we want to calculate 2 powered by 3, which equals to 2 times 2 times 2, we can use this exponential operator in this case. If I do 2 exponential operator and then 3, this is the equivalent of 2 powered by 3, and you can see that in the console we are getting 8, which is 2 powered by 3. And we also have the increment operator, which is two pluses near each other. For example, let's say we have a variable called x and we store 2 inside of this x. Now if we want to add 1 to this x, we can do x equals to x plus 1. And now we will have 3 stored inside of x. But there is an easier way to do this. Instead of doing x plus 1, we can do x plus plus, and this basically adds 1 to x. And now if we console x, you can see that we have 4 stored inside of this x variable. And similar to increment, we also have the decrement operator, which is 2 minuses together. For example, now if you want to decrement 1 from x, you can do x equals to x minus 1. And now you will have 3 stored inside of x. But an easier way to do this, you can basically do x minus minus. And now if you log the x, you can see that we have 2 stored inside of x because we subtracted 1 from this 3. And these are all of the arithmetic operators that you need to know. I would say the most used ones are these basic operators, and then we also use the increment and decrement in for loops, which you will see in the next section. But it's good to know all of them because you might also need to use this exponential or modulo sometimes in your code. And this should be modulo, not module, so this is just a typo. Now let's move on to the next type of operators, which is comparison operators. We already used one of them, which is strict equality. For example, if we want to check if 2 equals to 2, we use this strict equality and then we get the result in the console, which is either true or false. For example, if I check 2 strict equals to 3, we should get false in the console because 2 is not equal to 3. Strict equality also checks for the type of these variables, not only the values. For example, if I do 2 equals to 2 string, and the result of this will be false because this is the number 2 and on the other hand this is the text 2, and these are not equal to each other because they have different types. But on the other hand we have loose equality, which is 2 equal signs instead of 3, and this operator checks if 2 values are equal after converting them to a common type. For example, if we do 2 equals to 2 text, you will see that we get true in the console, and that is because this loose equality converts them to the same type. So this operation is the equivalent of 2 strict equals to 2 because it converts this second string to 2 number and then does the comparison, and that's why we get true in the console. But in most cases, this is not the recommended way in JavaScript to compare numbers or anything. If you want to compare two variables in JavaScript that don't have the same type, you better convert one of them to the same type and then use the strict equality here instead of using this loose equality. And this will help you avoid unexpected results when comparing values of different types. Similar to equality operators, we also have the inequality operators, which is written like this. For example, if we define a variable called x and assign value 3 to it, and for instance, if we want to check if this x is not equal to 2, we can use this inequality operator, and now we will get true in the console because x is equal to 3 and it's not equal to 2, and that's why we get true in the console. Next we have greater than operator, which is written like this. For instance, we can check if x is greater than 1, you can see it's true, and if we check x is greater than 4, you can see it's false because x equals to 3 and it's not more than 4. And similar to that, we have less than operator, which is written like this. We can check if x is less than 1, which is obviously false, or we can check if x is less than 4, which is true because 3 is less than 4. And lastly, we have greater than or equal, which is written like this. For instance, if we do 3 is greater than 3, we will get false because 3 is not greater than 3, but they are equal. So if we compare 3 is greater than or equal to 3, in this case we will get true because we are also checking if they are equal, and in this case they are. That's why we get true in the console. And the last one is less than or equal, which is the same as greater than equal, but with the opposite sign. For example, 4 is less than 4 is false, but if we do 4 is less than or equal to 4, now we will get true in the console. And these are all of the comparison operators that you need to know in JavaScript. Now let's move to the third group of the operators, which are the assignment operators. Assignment operators basically combine an arithmetic operation with assignment. For example, if we declare a variable called a and we assign 1 to it, let's say we want to add 5 to this a, we can do a equals to a plus 5, and after this operation the value of a will be 6. But there is a shorter way to do this with assignment operators. For example, we can do a plus equals to 5. And this basically is the same as writing this. So in this case, we add 5 to a. And since the value of a is currently 6, this basically means 6 plus 5, which will be 11. So now we will have 11 stored inside of a variable. And we have similar shortcuts for subtraction, we have similar shortcuts for multiplication and also for division, which are just doing the same. We also have the shortcut for modulo and also for the exponential. And these are all of the assignment operators. Now let's move on to logical operators. First we have the logical AND operator, or it is more common to write it like this. Let's say we want to check two conditions at the same time. Let's first declare two variables. Let's set the value of a to be 1 and let's set the value of b to be 2. Let's say we want to do two operations at the same time. Let's say we want to check if the value of a equals to 1 and also the value of b is equal to 2. We can use this AND operator here to combine both of these together. And basically this means that if both operators on the left and right side are true, only then we will get true. For example, if one of these operations is false, let's say we are checking if a equals to 2 and b equals to 2. Now we will get false in the console because this first part of our operation is false, and no matter what comes after this result will be false because we are checking with AND operator. Another logical operator is the or it's more usual to write it like this. For example, if we do this same operation here but with OR operator, this will check if the left operator is true, and if it is not, then it will check if the right operator is true. And this results in true if at least one of these operations are true. In this example, it first checks if a equals to 2, which is false. Then it moves to the next part of the comparison, which is if b equals to 2. And the result of this is true because we have b equals to 2 here. That's why we get true in the console. And the last logical operator is the NOT operator, which is written like this. This basically reverses the operation. For example, if we do not true, this will result in false, and if we do not false, this will result in true. And one more thing to know about logical operators is they are not always providing us true or false values. For example, if we do true and false, here obviously we will get false because one of these is not true, and that is the second part of the operation. But this doesn't mean that logical operators always return true or false. Let me show you one useful example. Let's say we have let user variable, which should hold the value of user details, and for now this is undefined, meaning we don't have the user details yet. And then we have another variable which is default user, and in case this user is not defined, we assign some default user to this. Let's say we set it to guest. So in case user provided their name, we can call them with their name, but if they didn't provide it, then we want to call them with guest name. So let's say we want to create another variable which is based on these two values, which is called display name. And we want to assign this to the username if it was provided, and otherwise we want to assign it to guest name. Now we can do this with if-else statements. We can do if user, and in this case we set the display name to be equal to user, and then we can do else, meaning that the username was not provided. In this case we can set the display name to be equal to default user. And if we hit enter, you can see that now we stored guest inside of display name instead of the user because they didn't provide us with their username. But most often we can use logical operators to shorten our code. For example, now we can use logical operator or instead of doing all of these if-else statements. We can assign the display name variable to user or default user. And this means that we want to use this default user in case the username was not provided, and in case this was provided, we won't continue the rest of the operation and we will assign display name to user. And this basically results in the same thing as we have above, but you can see that the code is much shorter than this code. And let's summarize with the last operator type, which is the ternary operator. The ternary operator is a shortened way to write if-else statements in a single line. Let's say we have the same scenario where we have username and then default user. And now if the username was provided, we want to call them with their name, and otherwise we want to call them as guest. We can also use ternary operators here to shorten our code. And to shorten this, we can use this condition here. So we do user and then question mark. And after the question mark comes the code which will be executed if this is true, which is this part. So we will set display name to user. And after this sign comes the second part, which will be executed if the user is false. And in our case, it is the default username. Let's go through this again. We assign display name to either user or default user, and that is based in if the username was provided or not. So if the username is undefined, which is in our case, this will mean that this is not true, so we won't execute this part of code. In this case, it will be assigned to default user, which is guessed. And in case this was true, let's say we had some username like John assigned here. In that case, we will execute this part of code and we will ignore this second part. If we hit enter, you can see that this display name is get set to guessed, and that's because we don't have the username defined, it is undefined, and that's why we set it to default username, which is guessed. And these are all of the operators that we have in JavaScript. Now this was a lot of theory without any practice, so now let's come back to our calculator and let's try to incorporate these new operators that we just learned. Let's make our calculator a bit more robust by adding some input validation to it. If we go back to our index.html file, you can see that we already have some basic input validation, which is we expect the type of this input to be number. And this means that if you try to type something else in the input that is not a number, let's say you want to type the letter A, you won't see it displayed on the screen, and that's because this is validating the input and it's not letting you write anything that is not a number. But for now, let's remove this and let's see how we would implement an input validation in the JavaScript file. If you remove that type validation from here, now we can type letters here, and let's say these letters plus these letters, and we can hit calculate. And you can see that in that case we are getting an issue here, and that's what we need to fix in our JavaScript file. And that means that before doing any operation here, we first need to check the type of first and second number. And then based on that, we decide if we want to move further or we want to do something else with it. First, let's console.log the first and second numbers and let's see what we get in the console. Now, if you open the console here and we write something here, let's say A and then plus B, and we hit calculate, you can see that in the console we get two nuns, and none in JavaScript is a number type, which means that there is no number here. None stands for not a number. And let's see why is that the case for us. And that's because this first number comes from the parseFloat JavaScript function, and we take the first input value and we try to convert it into a number. We can see this in the console. If you try to get the value of parseFloat and then you pass the A string to it, you can see that we are getting not a number here, and that's why we have that in the console. And to prevent this from happening, we can check if the value of this equals to none, and then we can do something else instead of calculating the result. And we can check that by using another built-in JavaScript function, which is called isNone. And inside of the brackets, you pass the number that you're trying to check. And we need to do the same for the second number. We need to check if this is none and save it. And now if you try to do A plus B and hit calculate, you can see that we get two truths here, which means that the first number is none and also the second number is none. And one example solution that we can do here is we can check if the first number is none by doing isNone first number. And here, instead of showing that none value, we will display an error message saying that the first input is not correct. So instead of displaying the result paragraph as result and number, we will push another thing inside of this text content. And here we can, for example, say, please enter a valid number. And we also need to return out of this function. And this means if the first number is not valid, we will get inside of this if statement and we will push this inside of that paragraph. And then instead of performing these other operations, we return, which means that we exit out of this calculate function. If we save our changes and try to do it again, let's do A plus 2 and hit calculate. You can see that it says please enter a valid number here and it doesn't show you none in this case. Now if we try to do 2 plus B and hit calculate, you can see we are still seeing that none, and that's because we didn't check the second number here. So what we can do is we can copy this if statement, and here instead of first number we can check the second number. This means that if the first number was valid, then we will get inside of this if statement, and if this second number is not valid, we will again have the same error message displayed on the screen. Now if we try to do 2 plus p and hit calculate, we will see the same error message. And if we try to do a plus 1 and hit calculate, we again have this same error message asking us to enter a valid number. But we can shorten this code by using the logical operators that we just learned. First, let's get rid of this console log here. If we have a look at the logic here, what this basically means is that if the first number is not valid or the second number is not valid, then we will display this text instead of displaying the calculation result. And since we have the same exact code in these two if statements, we can combine them together by using the OR operator. We can remove this second if statement completely, and here we can do OR operator and then check if the second number is also not a number, and this will have the same result as having two if statements for first and second numbers. But instead we are now doing both of these in the single line, and we are reducing the code duplication of these two lines. We can save and verify that this also works. If I try to do 3 plus 2 and hit calculate, we will get this error message here. And if I try to do valid number in the first input but invalid number in the second input, we will see this error message again. And if we try to do both of them as invalid numbers and hit calculate, again we see the same error message. And otherwise, if we try to do 6 plus 6 and hit calculate, now we will see the result because both of them are numbers, so we will pass this if check. And then we will get into the calculation process and then we will display the result in the screen. Now if we go back to our index.html and add this type equals to number again, now we will have two validations in place. We will have the first validation in HTML file, which doesn't let you write any text here. But even if we forget to add this type number, we will have the second validation in the JavaScript, which is still checking if the number is a valid number, and otherwise it returns an error on the screen. And actually there is one more validation that we can add. Let's try to do 4 divided by 0 and hit calculate. You can see that the result is infinity. We know this from math that 4 divided by 0 should result in infinity, but actually in calculators we shouldn't display infinity here. We should instead notify that division by 0 is not allowed here. And that is happening in this third scenario where we have the division operator. Here, before calculating the result, we need to add some other validation in place. And that should be to check if the second number that we have here equals to 0. And in case this equals to 0, we need to display some message on the screen instead of doing the calculations. So we shouldn't proceed to this line and instead we should show some error message here. And we can again copy the paragraph text content here. And we can display some message saying that division by 0 is not allowed. And if you remember, we should again do the return statement here. Otherwise, this calculate function will proceed to the next line and it will do the division. So we should add this return statement here to pause the execution and to exit out of this function. If we save our code and try to do a division by 0, let's say 3 divided by 0. And if we hit calculate, you can see that we added another validation and now we are not letting users to use 0 as the second input when they are performing divisions. Let's implement the last improvement on our calculator, and that will be to get rid of this if-else statement chain and instead use the switch statement in JavaScript that we will learn now. As you can see here, we are using a chain of if-else statements to determine which operation we need to perform. And while this works, there is a better way to do this, and that is with switch statements in JavaScript. In JavaScript, we can use the switch keyword to start a switch statement. And then we open the brackets, and inside of the brackets we will have the variable which we try to evaluate. In our case, that variable will be the operator, so we are trying to perform operations based on the value of this operator. And then we open the curly braces just like we do in the if statement. And then we use the case keyword inside of switch, and each case represents a possible value of the expression. For example, one case of this can be if the operator equals to plus, and in this case we need to perform some calculation. And we define that calculation in front of this case statement. We know that in case of addition we need to perform this calculation. So we need to copy that and paste it on the next line of this case of the plus icon. And then once we are done with the code, we need to add the break statement here. This statement is very important and it tells JavaScript to exit out of this switch block after the match is found. And if you don't include this break, it will just mean that the code will fall through to the next case even if it doesn't match. So this will be the first case in our switch statement, but we know that we have 3 more cases of this operator. We can add the next case here, and in the next case the operation will be minus. And here we need to perform this other calculation. So we will copy this and we will paste it below this second case here, and then we will add the same break statement below that. And continuing from here, we can have another case, and that will be multiplication. In case of multiplication, we need to copy this part of the code and paste it below the case of the multiplication and then add the break statement. And in case of division, we need to add another case here for that. And in that case, we need to copy this piece of code and paste it below the case statement there. And let's not forget to add the break statement after this case. Now what about this other case where the operator is invalid? Well, in switch statements for that we have the default value. So below all of the cases we can add default here. And this is an optional case which is executed if none of the other cases are met. So if the operator was not plus, minus or multiplication or division, then we will get into this default state. And this is where we copy and paste the else case code. And now this switch statement is the equivalent of this code that we had here. But as you can see, the switch statement looks much cleaner and it's much easier to read this code than the if-else statements that we had below here. And with that we can get rid of this other code here and we can save this file. And now let's just verify that everything works here. If we do 1 plus 1 and calculate, the result is 2. If we do 3 minus 1 and calculate, the result is 2. If we calculate 3 times 2, the result will be 6. And if we try to do 3 divided by 2, we will get 1.5 here. And with this lesson, we completed the JavaScript building blocks first part, where we learned about variables and constants. We learned about primitive data types in JavaScript, which are numbers, strings, booleans, and so on. We learned about all of the types of operators like arithmetic, comparison, logical, and assignment operators. We learned how to use if-else statements and switch statements to control the flow of our application. And we learned about functions, and we use functions to perform calculations. And we learned how to declare a function and how to call these functions and how to pass them arguments and how to use the return values and so on. And let's move on to the next section where we will learn the rest of the building blocks in JavaScript. Welcome to this module where we will learn about the advanced building blocks of JavaScript. In the previous modules, we laid a solid foundation by understanding the basics of JavaScript like syntax, variables and constants, primitive data types in JavaScript, operators and control flow, and also functions and how to use them in JavaScript. And in this module, we will focus on the advanced concepts. We'll learn about the power of loops to automate repetitive tasks and iterate over data and create efficient code. Here you will learn about the different types of loops like for, while, do while, and others. And we will see the unique use cases of each of them by doing exercises to make sure you understand when to use each of them. We'll explore arrays, which are versatile data structures used to store ordered collections of elements. And here you'll discover how to create, access, and manipulate arrays using a variety of built-in methods in JavaScript. Next, we'll explore a very important topic in JavaScript, which are objects. These are just key value pairs that form the backbone of JavaScript's data organization, and you'll learn how to create an object, how to access its properties, and the different methods that we use on objects, and about the this keyword, which is an important concept in JavaScript. And if you remember, in the previous module we learned about the primitive data types, and in this module we will learn about the reference data types in JavaScript, which are objects, arrays, and functions, and what's the difference between reference and primitive data types. And the main difference between these is the way they are stored and manipulated in memory, and we will learn how this differs from primitive data types. And we will explore the this keyword in objects, which is an important concept in JavaScript, and also the call, apply, and bind methods, which are used to change the this keyword and the difference between these methods. And lastly, we'll learn about the scope, which is how JavaScript determines the accessibility of variables within different parts of your code. And here we will learn about the global, local, and block scope and the difference between them. And by the end of this section, we will complete all of these advanced concepts in JavaScript and overall the JavaScript building blocks, which will enable us to build interactive and advanced web applications. In programming, there are often situations where you need to repeat a certain action multiple times. Let's say you wanted to display a message "Hello World" in the console 10 times. You could write this code hello world in the console, and then you could copy this 9 more times, and that will be hello world 10 times in the console. But what if we want to console log the same thing for 100 times or 1000 times? Just copy pasting this same line will be very inefficient, and JavaScript provides us with a better way to handle these repetitive tasks with the help of loops. Loops allow us to execute a block of code repeatedly and also make the code concise rather than copy pasting the same code multiple times. The most common type of loop in JavaScript is the for loop, and here is the basic structure of a for loop. We have three parts in these brackets, and the first part is the initialization, the second part is the condition, and the last part is the final expression. The initialization part is where you first declare a loop counter variable and you set the initial value. For example, we can declare a variable named I and set the initial value to be 0. And then we have the condition, which is a Boolean expression that is checked before each iteration of the loop. And if it evaluates to true, the loop continues, and if it doesn't, then the loop stops. And in our example, the condition should be that whenever the I is less than 10, we need to continue executing this code. And the last part that we have is the final expression. This expression is executed at the end of each loop iteration, and usually we update the loop counter in this part. For example, we have the I variable here, we initialize it to 0, and then the condition is that it should be less than 10. And in the final expression part, we increment this I variable at every iteration, and this is just the equivalent of I plus equals 1, where we add 1 to I. But if you remember the increment operator, this is where it is useful. We use this increment operator in for loops usually to increment the counter of the for loop. And then just like functions, we have these curly braces, and inside the curly braces we define the code that needs to be executed for this for loop. And in our case, we just need to console log hello world, so we can copy this console log message and place it inside of the for loop. So to reiterate what happens here, we initialize our I variable to be 0, and this is the counter of our for loop. And then this condition is checked before each iteration, and as long as I is less than 10, the loop continues. Inside of our for loop, we log the message hello world in the console. And at the end of each iteration, except only logging this message, we also increment the counter I by 1. And this means that on first iteration we have I as 0 and we log message hello world. And on the second iteration we have I as 1 and then we also log the hello world in the console. And this continues until I is 9 and then we log the hello world one more time. And then when the I is equal to 10, this condition is false, meaning the I is not less than 10. And in that case we stop executing this for loop. And this block of code does exactly the same as this first part, except we are using 3 lines of code, except 10. And if we needed to log this hello world 100 times, for example, instead of 10, we could just increment this I condition and set it to be less than 100. And we will still use the 3 lines of code instead of 100 lines of code, and so on. And that's the advantage of for loops in JavaScript. They allow us to execute a block of code repeatedly for automated tasks, and they make our code more concise. And this is the for type of loop in JavaScript, but we have other types of loops. For example, we have the while loop. And the while loop is another useful type of loop, and it keeps executing a block of code as long as the specified condition is true. And we specify that condition after the while statement. We open the braces, and here is where we will write the condition of this loop. And then we open the curly braces similar to for loop, and here is where we will write the execution code of this while loop. Let's say we wanted to count down from 10 to 1. We can define a variable here, let's say count, and it will start from 10. And here inside of the execution block, we will log that count. And after logging this count, we will also decrement it by 1 by using the decrement operator. And with this code, on each iteration, we log the value of count and then we decrement it. And our condition for this while loop should be if the count is greater than 0, then we should log this count, and otherwise we exit out of this while loop. And as you can see in the console, we will have 10, 9, 8, 7 and until 1. And when we set the value of count to 1, after that we will also decrement it and it will be equal to 0. So on the next iteration we will have 0 is greater than 0 and this will evaluate to false and this will exit out of this while loop. Similar to while loops, we also have the do while loops in JavaScript. And the main difference is that this type of loop guarantees that our code will be executed at least once, even if the condition is initially false. We define do-while loops by starting with do keyword and then the execution block of our code. And then we have the while and the condition that is inside of the while brackets. And this type of loop is less common than the while loop, but it can be useful in certain situations where you need to perform an action at least once before checking a condition. For example, if we set the same condition as we have in our while loop, which is count is greater than 0, since we already decremented our count value to 0, if I log the value of count here, you can see that it is set to 0 now. And if we try to console.log in this do while loop the value of the count, this condition is false since this evaluates as 0 is greater than 0, and that should mean that this shouldn't be executed, but that's the case of the while loop, and inside of the do while loop we execute this at least once, and as you can see we have the 0 printed in the console, and only after the first iteration it will see that the counter is not greater than 0, and that is where it will stop this loop. And let's also talk about infinite loops in JavaScript. It's important to be mindful of not getting stuck in infinite loops. These are loops where the condition never becomes false, like this condition in this do while loop or this condition in this for loop. And this causes your code to run endlessly, and it will also result in crashing the browser. And for that we need to always make sure that our for loops has a way to eventually terminate. Here is an example of an infinite loop. We can define a for loop and set the initial counter to be 0. And then we can check if the I is greater than equal to 0. And in that case, we will increment the I variable. And here you want to execute any code. Let's say you just want to console log some message. This message will keep printing forever. And that is because we started this I variable at 0 and we increment this variable on every step. This just means that I will be 0 and then it will be 1, 2 and then this will go to infinity like 1000 and then to plus infinity. And this condition basically will never become true and our loop will be executing forever. And we also have for in and for off loops in JavaScript, and these are for iterating over objects and arrays. For in loop iterates over the properties of an object. And for off loop iterates over the values of an array, or it can also iterate on an iterable object like strings, sets and maps, and this will make more sense as we learn about the objects and arrays in JavaScript. And we can also control these loops by using the break and continue statements in JavaScript. We can use break to immediately exit the loop, and we can use the continue to skip the rest of the current iteration and move on to the next one. For example, we can have the same for loop where we initialize the I variable and then we set some condition, let's say I is less than 100, and then we will increment our I variable. For now, let's just console log I here, which will be from 1 to 100 numbers. Actually, let's just set this to 10 so that we can see all of the numbers in the console. And here we can add a conditional. Let's say we are searching for number 5 in this I variable. We can set a condition that if I is equal to 5, and let's say in this case we want to exit out of this loop and we don't want to continue any further because we found the number we were looking for. We can set some console log message here saying that stopping the loop at 5. And on the next line we can use the break statement, and this will exit out of this for loop, which means that we will only log 0, 1, 2, 3, 4 and 5 numbers in the console, and after that we will exit this loop. And that is how we can use the break statement in our for loops. Now let's see how we can use the continue statement in a for loop. But let's say this time we want to only log the odd numbers on the screen, meaning 0, 2, 4 and so on. And for that, let's get rid of this condition here. We can add another condition and check if this number is odd by doing $2 and this should not equal to 0. This basically means we are dividing the number by 2. For example, let's say we are on 4th iteration. This will be 4 divided by 2 and the remaining part will be 0. So this condition will be false. But if the number is 5, for example, 5 divided by 2 and the remaining part of that will not be 0, so this condition will be true. And in that case, when this condition is true, we want to continue our iteration, meaning we don't want to log this number on the screen. As you can see, for now we have from 0 to 9. But if I set continue statement in this condition case, you can see that we only log these 0, 2, 4, 6 and 8 numbers on the screen. And now let's practice what you just learned. You have 3 exercises to complete. The first one is to print even numbers. You need to write a loop that prints all the even numbers from 2 to 20, which means that this loop should print 2, 4, 6 and all of the other even numbers until it reaches to 18 and then 20. In the second exercise, you need to calculate a factorial of a number by using a loop. So you need to write a loop to calculate the factorial of a given number. And if you don't know what a factorial means, it's basically the multiplications of all the previous numbers and until that number. For example, if you have factorial of 5, this is equal to 5 times 4 times 3 times 2 and the last number should be 1 and this equals to 120. And for example, if this was factorial of 6, we would just add 1 6 in front of this, and this would be 6 times the factorial of 5. And the last exercise is the guess the number game. So you need to create a very simple game where the user has to guess a randomly generated number, and this could be in a function, for example. And you need to use a loop to keep asking for guesses until they get it right. And you don't have to solve all of these exercises, just try to solve each of them for 10 to 20 minutes, and if you cannot, then come back for the solution. And if you'd like, I can give you some hints now on how to solve each of them. So for the first one, you need to use the for type of loop. For the second one, you need to use while type of loop. And for the third one, you will use the do while loop. So you will use all types of loops that we just learned, and you will also practice each of them in these exercises. Now let's solve these exercises together, and let's start from the first one where we need to print even numbers on the screen by using a for loop. So this should be the easiest out of these exercises. We just need to use the regular for loop and we need to loop through the 20 items and then print all of the even numbers. We need to define our counter, which can be I equals 0, and then we need to set the condition, which is until I is less than or equal to 20, because we also want to include this 20 in the list, and that's why we have less than equal instead of less. And then we will increment our I counter. Now here, if we just console log the I counter, you can see we have from 0 to 20, but we want to exclude the 1, for example, 3, 5, and so on. For that, we can add a condition in our for loop, and we can check if I is an even number by doing I percentage sign 2 is not equal to 0. And this basically means that after dividing I by 2, the remainder should be 0, and that is the condition of an even number. And in this case, we can use the continue statement that we just learned. And this will mean that whenever this condition is true, we are skipping this iteration and we are not console logging that number on the screen. And as you can see, after this condition, we are now printing 0, 2, 4 and all of the even numbers until 20. And that is one example solution for this exercise, but actually there is an easier way. We can remove this condition from our for loop, and instead of doing I equals to 0 and then incrementing I by 1, we can start our iteration from 2 because we know that this is the first even number. And then instead of incrementing our I by 1, we can increment it by 2 on each iteration, which means instead of doing I plus 1, we need to do I plus 2. And for that, we will use I plus equals to 2. And in this case, we start at 2 position, and on each iteration, we just add 2 to this number. So on the second iteration, it's 4. On the third iteration, it's 6, and so on. And by doing that, you can see that we have all of the even numbers in the console. And this is much easier to understand than the previous solution that we saw. Now let's solve the second exercise, which is to calculate a factorial of a number. And in this case, we will use while loop instead of for loop. So you will see this one in action as well. We can see from this example that all of the calculations of factorial numbers start from 1 and then we multiply it by 2 and then by 3 and then we do this until we reach that number, which is 5 in this case. And that means that the factorial of a number is at least 1, and that is in case we have 1 factorial, and this will be equal to 1. So we can initialize our factorial and this will be equal to 1 at the beginning. And we need one more variable, which will be the number that we want to calculate. For example, it can be 5, 6, and this is the number that we want to calculate factorial for. Let's just name this to be number, and for now let's assign it to 5 because we want to calculate the factorial of 5 number. Here we can use a while loop to loop through the numbers until 5 and multiply all of them. And regarding the condition that will be inside of this while loop, if you look at this example, you can see we do 5 times 4 times 3 times 2, and then we stop the loop whenever we reach to 1. So the condition should be whenever this number is greater than equal to 1. And until it is greater than 1, we will continue our iteration. We will multiply this factorial by the number that we have inside of this loop. And that means that initially this will be 5 times 1 and it will be 5. And on the next iteration we need to decrement this and set this to 4. Which means that on the second iteration it will be 4 times the number that we have in factorial, which is 5, and that will be 20. And we will do this same step until we reach to 1. And that is where we will exit out of this while loop. So below this calculation, we need to do number minus equals 1, which means that we are decrementing 1 from this number. But if you remember the shortcut for this, we can do number minus minus, which is the equivalent of subtracting 1 from this number. And this should be it for our factorial calculation. We can check the result by checking the factorial in the console. You can see that it's 120, and that's what we should expect for 5 factorial. Now if you want to calculate the 6 factorial, we will just change this to 6 and that will be 720. Or we can set this to 10 and this will be the factorial of 10. So to recap what's happening here, we initialize the number, which is 5 for example. And then we do a while loop and we continue this loop until the number is greater than equal to 1. On first iteration, we do 1 times 5, which is 5, and we assign that to the factorial number, and then we decrement the number by 1, which is now set to 4. On the second iteration, we multiply our factorial, which is currently 5, by 4, and that will be 20, and then we decrement it again, which is set to 3. And then we do the same iteration for 2 and then for 1. And once we reach 1, we see that number is greater than equal to 1. So we do our last calculation, which is 1 times the factorial of 5. And then we decrement the number by 1 again. And now it is set to 0, which means that this condition is not true anymore. And we exit out of this while loop. And our factorial is equal to 120 in this case. Now let's do the final exercise, which is the guess number game. First, let's generate a random secret number between 1 and 100, for example. We will initialize this variable with const because we know it won't be changed along this program. Let's name it to be secret number. Now you can hardcode this to be some number, for example, but if you want this to be generated randomly, we can use the math functions that we have in JavaScript, and the first one will be mathRandom, which is a static method that returns us a floating number, and this number will be within 0 to 1 range, and which means that we need to multiply it by 100. But since this can be a floating number, we need to round it, and for that we can use the other math method, which is called mathFloor, and then pass this inside of that function. And now this will hold a number between 1 and 100. And next we will accept the guess variable, which will be guessed number. And for this last one we will use a do-while loop so that you can see also the third type of loop in action. We will create a do-while loop here. And our condition should be whenever this guessed number is equal to the secret number, meaning we have guessed it correctly, we should exit out of this for loop. And otherwise, unless this is not equal, we should notify the user whether their guessed number is higher or lower than the secret number. So we'll create a conditional here with if statement, and we will check if the guessed number is lower than the secret number. In this case, we will console log too low, for example. And otherwise, if the guessed number is greater than secret number, then we will notify that the number is too high. And the last case will be whenever this is not less than secret number and it's also not greater than secret number, which means that it is equal to secret number. We need to console log that they won the game. For example, we can console log congrats, you guessed the number. And here we just forgot to add else if, so this is not else but else if statement. And now we can try this by assigning a number to guessed number. For example, if we set this to 20, you can see that it is too low. Now we need to try a higher number, for example 60. Now it is too high, and then you need to keep trying until you guess the number correctly, and you will see congrats, you guessed the number in the screen. And why we are using do while loop instead of a regular while loop? That is because whenever this guessed number equals to secret number, we will still do another iteration, and in the last iteration we will get inside of this else statement and we will be able to print this on the console. Whereas if you did this with a while loop, whenever this is equal to the secret number, it will exit out of that while loop, and that's why we used do while loop in this case. In the previous lesson, we learned how to use loops to repeat actions, and now let's explore a powerful data structure that often goes hand in hand with loops, and that data structure is arrays. Arrays are just ordered collection of items. You can think of them as lists where each item has a numbered position called an index. We define arrays inside of square brackets in JavaScript, and here we can pass the array items. For example, this can be an array of numbers like 1, 2, 3, 7, 10, and so on. And then we usually store these arrays inside of a variable. We can define a const array variable and then assign this to be the square brackets and then the array items inside. And these arrays can hold any type of data. For example, this one holds numbers, but we can define another array, and here we can store strings, for example. And this can even be mixed data types, meaning we can store multiple data types inside of single array. For example, we can have the first item as number, but then the second item can be string, and then we can have another value that is boolean, and then string again, and so on. But in the real world, this is not that common. We typically store the same data type inside of an array so that we can work with it easily. And this is very useful in real world. For example, you can store user data inside of arrays. Let's say you have multiple users in your application. You can store all of their data in an array and then do some operations with it easily. Or you might have a blogging platform where you have blog posts and you can store all of these blog posts inside of an array and then loop through them and render them on the screen and so on. Now let's see how we can access these items from these arrays. As I said, each item in this array has a position, and that position is called index. And this position in JavaScript starts from 0. So the first item will be at 0 position. The second item will be at 1 position. The third one will be 2, 3, and so on. And for example, if we want to access the 7 from this first array, we write the name of that array and then we again open the square brackets, and here we pass the position of that item, and as you can see the position of 7 is 3. So if we pass 3 here, we will access that 7 number, and to verify it, let's console log that number. You can see that if we do array 3 position, we get 7, and that's because this is at third index. For example, if we want to access 10, we can do 4, and this will be the fourth item in the array, which is 10. And actually, as you can see, this is the fifth item in the array, but since we are starting the counter from 0 on arrays, this is the fourth item by index, but it's the fifth item in the array. And since 4 is the last item, let's see what will happen if we do array and then 5 index. You can see we are getting undefined, and that's because we went out of the memory of this array. On the fifth index, we don't have stored anything. This is out of the memory of this array, and that's why we get undefined, because nothing is defined at this index. And there is a useful property on arrays which lets us identify the last element, and that is array.length. If I console log the length of this array, you can see it is 5, which means that we have 5 items inside. And this notifies us that the last element should be on the fourth index, and if you go beyond the fourth index, we will get undefined. Now let's explore the built-in methods of working with arrays in JavaScript. We have some common methods that we use often when we work with arrays. As an example, let's say we want to add another item inside of this array at the end. Let's say we want to add the number 12 here. We can use that push method on this array, and here we pass that number which we want to push at the end of that array, and we can pass 12 here, for example. And now if we console log that array, you can see that we added the 12th number at the end of this array. Similarly, we might want to delete the last item of this array. We can use that pop method on this array, and we don't need to pass any arguments here. This will just remove the last item of this array, and at the moment of calling this method, the last item is 12. So if we console log array here, you can see that now we removed that last item and we have the initial structure as we had before. And these are common methods for doing operations at the end of the array. But what if you want to remove the first item from this array? For that we have another method, and that is called shift. And this method will remove the first element from this array and it will also return it. If we console log our array after doing this shift, you can see that we removed the first item, which was 1, and now we have 2, 3, 7 and 10 inside of this array. And the opposite of shift is the unshift method, which lets us push a number at the beginning of this array. For example, I can push the number 100 at the beginning of this array. And if I console log our array again, you can see that the first number is 100 and we pushed it by using this unshift method. And these are just few examples. There are many more methods that we can use on arrays, and we'll encounter more of them as we continue building projects throughout this course. And remember that I said that loops go hand in hand with arrays, and that is because we usually want to loop through arrays and do some operations on them. And for that, let's learn how we can loop through arrays. There are multiple ways we can loop through arrays, and the simplest example is by using a for loop. We can use the traditional for loop, and we can set the counter to start from 0, which is the 0th position in the array, and that will be this number 100. And then our condition in this case will be until I is less than the array length. Remember, we have the length property on arrays, and that specifies how long we can go through this array until we encounter undefined memory. And until this condition is true, we will increment our counter and we will loop through this array in the for loop. And here we can access that array item by doing array, and then inside of these square brackets we will pass the I, which is the current item. So it will be 0 initially, then it will be 1, 2, 3, and then until we reach the 5th item, which will be 4, and then we'll exit out of this for loop. You can do any sort of operations here, but for now I will just console log this item to see what we have in the console. And you can see that we are accessing our items one by one. At first we have 100, then 2, then 3, then 7, and then 10, and then we exit out of this for loop. A more concise and readable way of this is to use for of loop that I mentioned in the previous lesson. Here is how we can use for of loops. We start with the same for keyword, and then here we can access each item of this array one by one by doing const item of array. And this basically means that on each iteration we are picking one item from this array. On the first iteration that will be 100, on the second one it will be 2, and so on. If we console log that item here, we will have the exact same result as in the first case. But this is way more concise and readable. Now obviously if you want more control, you would use this for loop, because here you also have access to the index, which you might need for some operations. But if you don't need access to that index, then this is a more readable way, and it's also shorter than this first one. But we have another way to loop on arrays, and that is by using the for each method. We can access that for each method on any array by doing array.forEach, and here we need to pass a function which will be executed on each array element. And that function takes an argument, which is the item in that array. On each iteration this will be changed and set to the next item. For now we can again console log that item, and you will see that we get the same items in order. So on each iteration this function is called with a new item. It starts from the first item, which is at 0 index, and then we gradually move on to the last item. So for each focuses on performing an action on each element without creating a new array. And on the other hand, for and for of offer more control over the loop, and they allow you to break or continue the iteration if needed. Let's do one small and simple exercise with arrays before we move on. So we have this exercise where first we need to create an array called cities, which will contain 5 different city names. And on the second step you need to use console to display the second city in the array. Next you need to add a new city at the end of this array. And in the fourth step you need to remove the first city from this array. And lastly we need to display the updated items of that array one by one in the console. So go ahead and try this on your own and then come back for the solution. Let's solve this by completing steps one by one. So first let's initialize a cities array. And here we just need 5 random city names, so I will just copy paste some city names here. Next we need to log the second city from this list. And to select it we need to use cities and then square brackets. And here we need to pass the index of the second city, which is London here. But if we pass 2 here, that will select Paris, and that's because the first item is at index 0, the second item is at index 1, and the third item is at index 2. So that's why we will need to use the first index here to be able to access the second city. Next, if you remember the method which adds an item at the end of the array, and that is the push method. We need to use the push method on our cities array and add another city at the end of this list, for example Berlin. And now if we console log cities, you can see that we have our initial array and at the end we have the last city that we just added. And to remove the first city from the array, this is another method that we just discussed, and that is the shift method. If we do cities.shift, this will remove the first item, and now if I console log the cities, we can see that the first item, which was New York, was removed from this array, and now we only have the items from first to the last index. And lastly, to display these items one by one, we need to loop through them, and we can use one of the free loops that we just saw. For this case, I will choose to use for of loop. So we will start with the for keyword, and here we will take one item per iteration. So we will do const city of cities. And now we just need to console log each item in the console by doing console log city. And this will print each city per iteration. So on the first iteration it will be London, in the second one it will be Paris, and so on until we reach to the last city in our cities array. Let's discover another powerful data structure in JavaScript, which are objects. Objects are collections of key-value pairs. You can think of them as dictionaries, where each key, like a word in a dictionary, is associated with a value, like a definition in that dictionary. And keys from here are usually strings in the object, but the values can be any data type, and this includes the objects, arrays, functions, and all the data types that you know. And this allows us to create complex and nested structures. So objects are perfect for representing real-world entities or grouping related data together. Let's see how we can create objects in JavaScript. We can use object literals or curly braces to define the object structure, and then we usually store this inside of a variable. Let's say we define a variable light bulb and we assign it to be this object. And inside of the object we have that key value pairs that we talked about. An example key here can be is on, which indicates whether this light bulb is on or off. And in front of it we define the value, which can be any data type. And in this case it can be boolean. For example, this can be false. But we can use another example key value pair. For example, we can set the color, and now we can use string. For example, we can set this to be yellow. And as I mentioned, we can also use the complex data structures like objects and arrays, and we can nest them inside of this object. And we can also use functions, and functions inside of the objects are called methods, but they are just regular functions which execute our code. For instance, we can define a method here to be called toggle. And this can be a method which toggles on and off this isOn property. So here we can assign this to be a function, and then we can write the code that will be executed when this toggle function is called. And here the object can use its own properties by using the this keyword. And we'll come back to this keyword in a second, but for now you can see that we can access all of the properties that this object has access to. And we can take the isOn property and we can assign it to be the reverse of that isOn property, which means that if this is set to false, now it will be set to true. And if it's true, then it will be set to false after calling this toggle function. And that's how you can create objects. Now let's see how we can access the properties of this object. We have two main methods to access the properties in an object. The first one is using the dot notation. To use the dot notation, you write the name of this object and then you use the dot notation. And here you can see that we can select all of the properties or methods that exist on this class. For instance, we can select the isOn property and we can console.log to see what's inside this here. You can see that it's false for now. And what if we call the toggle method that we just defined? Let's console log the lightbulb.toggle. And like this, we just access the method, but we also need to call it, which means we need to call it like a regular function. And since this function doesn't return anything, we just see undefined here. But if we console log isOn on the next line, you can see that now it is set to true. And this is how you can access the properties of an object and also how you can call the methods that will modify the properties on this object. And there is a second way to access properties on an object, and that is using bracket notation. Instead of calling it like this, light bulb and then dot isOn, here we can access that same isOn property but by using the bracket notation. But generally you would use this dot notation when you know the property name in advance and it's a valid JavaScript identifier, because it's more concise and it's easier to read. But bracket notation also has its use cases. This can be used when the property name is stored in a variable or it contains special characters, and it's also useful for dynamically accessing these properties. Let's say you have this color key stored in a variable, which is called light bulb color, and this is set to color. In such cases, you can use the bracket notation to access it by using the variable that you have. And if we console.log, you can see that we are getting that color from the light bulb object. And lastly, let's see how you can add and modify properties on an object. You can add properties to this object or modify the existing bounds by using either dot notation or bracket notation. You can use the object that you have, and then with dot notation you can add a new property, and here you can assign a value to it. For example, this can be anything like boolean or string or anything else. And you can also modify the existing properties. For example, if you want to modify the color of this light bulb, you can assign it to a new value, and here you can type the name of the new value. Let's come back to this keyword, which we saw in the previous lesson. In JavaScript, the this keyword is a bit like a chameleon. It changes its meaning depending on how and where you use it. You can think of this as a reference to the object that owns or calls this function. For example, in this case, we used this inside of the toggle, and this toggle is owned by the light bulb. So this means that this is referring to this light bulb class. Let's have a look at another example. Let's say we have this my account, which is a bank account, and you have the balance, which is how much money you have in this bank account. You have the deposit, which deposits money from this bank account, and you also have a withdraw method, which withdraws money out of your account. So when a function like deposit is defined in this class, you can use the this keyword inside of that function, and this will refer to this object, which is my account. And this is what allows these methods to access and manipulate the object's own properties. For example, here you can access the balance, which is this balance here, and you can add money to it, and you can also log it by using the this keyword. And similar to that, in the withdraw function, we also access the balance, which is the same balance that we have on this my account. And this way we make sure that both deposit and also withdraw methods use the same balance attribute, which is the balance property on the my account class. And just to verify, if we have a look at the my account, you can see that the initial balance is 1000. We can do dot deposit and add some money to it, for example 500. And now if we have a look at that my account, you can see now the balance is 1500, and we can also similarly withdraw money from it. We can withdraw 200 out of this, and if we have a look at the my account again, you can see that the same balance was subtracted and now it's 1300. So that's what this refers to in the methods. Now let's look at what this refers to in global context. If you call a function like this anywhere outside of the object, which means that it's in a global scope, this in that case will refer to the global object, which is usually the window in the browsers. And there is also a third case, which is this keyword in arrow functions. So to understand this, let's first understand what are arrow functions. Until now, we have used the regular functions in JavaScript, which are defined like this. Let's say this is a deposit function. This was the structure you would define a function in JavaScript. But in modern JavaScript, we have another way to define a function, and that is by using arrow functions. Similar to the above function, we can define another deposit function. Just in this case, we will assign it a bit differently, so it will be assigned like this. But basically, this and these functions are exactly the same, and the only difference is their definition. The first one is a regular declaration of a function, and the second one is a declaration of an arrow function. So you could write the same body inside of both deposits functions, but this one has some key differences compared to traditional functions, and one of which is their behavior with this keyword. For instance, if we have another object where we have some properties and then two methods, and the first method is traditional function, which is defined like this, and the second method is this arrow function, which is defined like this. The arrow function won't have their own this binding, and which means that they inherit this value from the surrounding enclosing scope where they are defined. And to understand this on an example, if you call traditional function like this without accessing it from this object, you will have this, which will refer to the global object, And the same will apply to the arrow function. If you access it like this without accessing it through this object, this will refer to the global object, which is again the window. But if you use them as methods of an object, if you call the traditional function on this myObject, this will refer to that myObject, and you would have access to all of the properties that this myObject has. But on the other hand, if you use the arrow method here, which is the arrow function that is defined here, and now we are accessing it through this myObject, in this case, this will still refer to the global object, and this will not refer to that myObject, which means that you won't have access to the name and other properties that this myObject has. And that's the main key difference between arrow and traditional functions. And you just need to choose one which fits in your scenario. For example, if you want to have access to the properties of this object, then you would use a regular function, and otherwise you would use an arrow function. But even if you use the arrow methods, you can still explicitly set the value of this when calling a function, and that will be by using the call, apply, and bind methods in the JavaScript. And I'll leave this useful resource below this lesson, which I think perfectly explains the difference between call, apply, and bind, and when to use each of them. But to recap, we saw that this behavior depends on how the function is called, and in methods this refers to the object, but if you use this in the global context, then it refers to the global object, which is window in JavaScript. And this also varies depending on if you use the traditional function or arrow functions, because arrow functions inherit these from their surrounding scope. And we also have the call, apply, and bind methods in JavaScript, which let you control the value of this. And if you want to change it to point to something else, you can do that by using these built-in methods. Destructuring, spread, and rest are operators in JavaScript, which are very useful when working with objects and arrays. Let's start with destructuring, which provides us a convenient way to extract values from objects and arrays and assign them to variables. Let's say we have this object person, which has a name, age, and also city properties. If we now want to access its properties, let's say we want to access person.name, we can access it with this dot notation, which we learned in the previous lesson. And then we can maybe access another property like age on this person. But if we are going to repeat this many times in our code, let's say we are going to use the same name property throughout our code many times, it's better to assign it to variable and then reuse it. And we can do it by assigning a variable to this, but there is a better way to do that, and that's with destructuring. With destructuring, you can use curly braces on the left side to specify the properties you need to extract, and on the right side you specify the object, which can be person here. And now here inside of these brackets, we can specify the variable names on the left, and these should match the property names in the object, meaning if we want to assign a variable for the name property, we need to name this as name, because that's what we have also in the person. And if we want to extract the age property, we also need to name the variable as age. This should match exactly the age which we have in the person. And by doing this, we now destructured the name and age from this person, and we assigned them to variables, which we can use throughout our code. Now if we console log the name and age, you can see that we have the name stored inside of the name variable, and we also have the age stored inside of the age variable. And this destructuring also works on arrays. Let's say we have this example array here. We can also extract elements from this array and assign them to variables. The simple way that we can do this is by assigning a variable to this, let's say first fruit, and we can assign this to be fruits.0, which is the first item, and that is the apple fruit in here. But we can do this same thing with destructuring. We can assign square brackets on the left side and the array name on the right side. And here, unlike the object, the naming isn't very crucial. As you saw here, we should name this to match exactly the property that we have in the object. But here we can name it whatever we want. We can say first fruit here, for example, and we can say second fruit for the second one. And this will extract the apple and store it inside of the first fruit, and this will extract the banana and it will store inside of the second variable. And we can verify that by console logging the first one and also the second one. You can see that we have apple in the first one, and in the second one we have banana. Now this second case is useful when you don't have too many items in the array. So usually when you have 2 to 3 items in the array, you can use the destructuring method to destructure the items from that array. Now let's have a look at the spread and rest operators, which both use the 3 dots like this. So they use the same syntax, but they have different purposes depending on the context that we use them. Let's say we have this example object which contains the defaults for products like the color and also the size. So if you don't assign anything, then it will be blue and the size will be medium. And now we want to create a product object and we want to set the default values if they are not assigned, and we also want to add some more properties to it. We can use the spread operator in this case to copy all of these values inside of the product and also add additional properties. And we do that by using the 3 dots and then specifying the object name that we want to spread here, which is the defaults. And after this, we can start adding more properties to it, like we can set the price to be 10 and we can set the name to be t-shirt and so on. And what this does, if we console log the product here, you can see that we have our assigned price and name at the end of this object, but we also have the color and size, which was spread from these defaults, which means that we basically copied these properties and we paste it here. So that's the exact equivalent of using the spread operator, but we do it with 3 dots and using the defaults, because this can be a bigger object and we don't want to manually copy and paste all of the properties here. So we do that by using the spread operator. The spread operator also works on arrays. For instance, if we have an array of numbers and now we want to create another array which will contain all of the items from this first array plus some additional items, we can create another variable. Let's name this more numbers. And here, if we want to have that same items plus the additional 4 and 5th item, we can use the spread operator on this array, and instead of copy pasting this, we can use the spread operator and spread the numbers from the first array inside of this second array. And now if we console log that more numbers, you can see that we have that additional 4 and 5th items, as well as the original items that we had in the numbers array. And that's how you can use them on objects and also on arrays. But what about the rest operator, which looks exactly the same as this spread operator? Rest operator is used in function parameters. Let's say we have a function, and this time let's use an arrow function, and let's name this function as sum, which will be responsible for summing the numbers that you provide in the arguments. So here we will have the arguments, and then after that we will have the function body. And if we know the argument numbers that we will have, let's say we will only have 2 arguments here, a and b, we can return a plus b in that case. But what if we don't know how many arguments we will have and we want this to work dynamically? In that case, we can use the spread operator here, which means that we will spread the numbers that we are getting as arguments. And inside of the body, we can first define the total, which will be the total sum of these numbers. And initially it will be 0. Then we can loop through these numbers by using the for each method. And for each number here, we will increment the total by doing total plus equals the number, which will be the provided argument. And then we can basically return the total, which will be the sum of all of these numbers. And this means that now we can use sum in different ways. We can use sum for 2 numbers like 1 and 2. And let's console log this. You can see for these 2 numbers it returns the sum, which is 3, but now we can provide additional arguments, like we can add 3 to this and it will also calculate the sum of this one and it will be 6, and we can continue adding as many numbers here as we want and it will just take all of that numbers here and then we can perform some operations with it, and that's how we use the rest operator on functions. And let's do a short exercise to apply the destructuring, spread and rest operators. So first you need to create an object which will represent a student with these properties: name, age, grade and favorite subjects, which will be an array. And then you need to use the destructuring to extract these properties, which are name and grade properties, from this object into variables. After that, create a new object which will represent another student, and here you need to use the spread operator to copy some properties from the first student and also add new ones for the second student. And lastly, you need to write a function that takes a variable number of arguments and it uses the rest operator and calculates their average. So try this on your own and then come back for the solution. Let's solve this by starting from the first point, which is just creating an object that will represent a student. So we will create a new object. Let's name this to be student. And here we need to add the attributes for name. let's assign this to be John. We need to set the age property for the student and also the grade attribute, which will be the grade up to 10. Let's say this one is a 10. And we also need to define the favorite subjects of this student. And this should be an array of subjects. For example, the first one can be math, the second one can be science, and so on. And after creating this, we need to use destructuring to extract the name and grade properties into variables. Of course, we can access it by doing student.name, but we will use destructuring here. So we will do const. The first variable will be name, and remember that this needs to be exactly the same as we have it in the student object. So this will be named as name, and the second one will be named as grade. And we will destructure those from the student object. And now if we console log the name and grade just to verify, you can see that we have John, and for the grade we have 10. But before moving to the next one, let's also use the destructuring on arrays. We see that here we have the favorite subjects. Now let's try to destructure this by using the array. So first we will destructure it from this object by doing favorite subjects here. And now we need to destructure the individual subjects that we have inside of this array. So we can do that by using the array destructuring this time. And here we can assign the first one to be first subject and the second one to be second subject. And we can assign this to favorite subjects. And with that, if we console log the first and second subject, you can see that we get the math and science, and this time we use the array destructuring to destructure these properties. Next, let's create a new object which will represent the second student, and here we will use the spread operator to copy some of the properties, and we will also add new ones. For that, we will create a new student. Let's name this student 2. And let's say this student has the same interests in favorite subjects and also has the same grade, which is 10, but the name and age will be different. For that, here we can use the spread operator. So first we will spread the student1, which is student object, but we will override the name and age properties. So for name, we can set this to be Emily. And for age, we can set this to be 17 in this time. And now if we console log the student2, we can see that grade and favorite subjects are coming from the first student because we used spread operator here. But the name and age are overwritten, and these are provided by the second student object. And lastly, let's write a function that takes a variable number of arguments, and it uses the rest operator to calculate their averages. Let's use a regular function this time, and let's name this to be calculate averages or calculate average. And here, since we don't know the number of arguments that we will receive, we again need to use the rest operator. So we will do rest numbers, which will be the number arguments that we receive in this calculate average function. And here we basically have an array of numbers, and we need to calculate their averages inside of this function. So the way we can calculate it is by doing sum of all of the numbers and then dividing it by the length of these numbers. Let's say we have 10 numbers. We can sum all of these 10 numbers together and then divide that by 10, and then we will get the average and return it from this function. So first let's define the total, which will be total sum of these numbers, and initially this will be 0. Then we need to loop through these numbers, and here let's use the for each again. Let's loop through the numbers by using for each, and on each iteration we will get the number. And here we just need to increment the total sum, so we will do total sum plus equals to the number that we have in the loop. And by the end of this for loop, we will have the total sum of all of the numbers. So here we can just return the total sum divided by the length of the numbers, which we can access by doing numbers.length. And let's try and see if this works. Let's do console log calculate averaged function, and here we can provide the arguments. So we can do 1, 6, 8, 0, and the total will be 3.75, and that's because if we sum all of this, it will be 15, and if we do 15 divided by 4, we will get 3.75. So that's it for these exercises, and hope you were able to solve them yourself. And if not, don't worry, because you will get good at this once you start doing this more and more. In JavaScript, all data types can be classified into two fundamental categories. That is the primitive types, which we already learned, and also the reference types, which are the objects, arrays, and functions. So the primitive types are the ones that we already knew, like numbers or strings, booleans, which are true or false values, the null value, which is null in JavaScript, and also undefined values, which are undefined. But apart from this, we also have the reference types, and these are objects, arrays, and also functions. So these are called reference types in JavaScript. And there is one key distinction between reference types in JavaScript and primitive types in JavaScript, and that is how these types are assigned and copied in the memory. First, let's start with primitive types. When you assign a primitive value to a variable, let's say you have a variable x and you assign a primitive type like number 5, a copy of this value is created and stored in the variable's memory location. And if you assign another primitive value, let's say y, and you assign this to be the same as x, another copy is created for this y variable and it is stored in the memory. So now if we try to change the x and let's set this to 10, and if we console log both of these values, the x and y, you can see that for x we have 10 because we just reassigned it, but for y we still have 5 because we created a copy at this point and y is still assigned to 5 and it wasn't reassigned to 10 like x. But where this gets different is for reference types. Let's say we have an object called object1 and this object has a single property name, and for this one it is set to Alice. And when you assign an object to a variable, the variable stores a reference memory address to that object, and multiple variables can reference to the same object, which means that if we create another object, let's name this to be object2, and we assign this to be the same as object1, in this case, unlike the above example, a new memory is not created. It is basically pointing to the same object that we have here for the object1. First, let's console log both of these. Let's console log the object1 and object2. You can see that for now we have set both of their names to Alice, and let's say now we want to change the object2 name and we want to set this to be Bob. If we change it to Bob, you can see that both of their names have been changed, not only for object2 but also for object1, and that is because both of these objects, the first and second one, are pointing to the same object in the memory, and when we change one property on one of them, we also change it for the second one. And this is important to know because if we wanted to change only the second object's name, we will get unexpected errors in our program. So for such cases, you need to create a copy of that object, which means that it will be copied into another memory in our program. And let's say we create a new object, let's call it object3. We can destructure the object1 here, and this means that we created a new object and we destructured the properties here, but we haven't assigned this to be the same memory as the object1. And if we do it this way, now we can change the object3 name and we can set it to something new, like new name. And let's console log it here near the object2. You can see that for object1 and object2, we are using the same memory and both of their names are the same. But for the object3, we have this new name and we haven't modified the previous names of the first object. And this is important to understand because in your program you might have scenarios where you need to use the same object, and in that case you can use it like this and you will also save some memory because you are using the same object for two variables. But you might have some cases where you need to copy the object but also add some additional properties without modifying the first one, and in that case you need to use something like destructuring and create a new copy of this object, which means that it will be copied into a new memory slot in your program. And that same thing applies to arrays and functions. Let's say we have an array which is numbers from 1 to 3, and then we assign the second array to be the same as first array. You can see them in the console here. Now if we want to add a fourth item in the second array and we assign this to be 4, you can see that array 1 was also modified, and that is because we are using these same memories for both array 1 and array 2. And if you don't want this to happen, you can still use the destructuring but in arrays, and you can destructure the first array here, and then in this case you will have 1, 2, 3 in the first array, but 1, 2, 3 and also the fourth item in the second array. And this is also important when working with functions. Let's say you have a function which changes the value of the number that you provide, and here we have single argument which is number, and just as a simple example, let's say this changes the number and sets it to 10. And when you pass a primitive value like a number to a function, the function receives a copy of that value, and the changes that are made here are made within that function and they don't affect the global variable. And what that means is, let's say we have a number 1 variable here and we assign this to 5, and now we pass it to this change value which changes that number 1 and sets it to 10. If after this operation we console log that number 1, we see that it is still 5 and it wasn't modified and set it to 10, and that's because this operation is happening inside function body and it received a copy of that number, so this num is not exactly the same as number 1, and when we do some modifications here, we do that on a copy of this number and not the same number that we have here. But this changes when we use reference types inside of a function. Let's create another function, and this one will be responsible for changing the name on a person object. So here, once we receive the person object, we will alter the name property and we will set it to be Bob, no matter what it was initially. In this case, when you pass an object, meaning reference type, to a function, it doesn't receive the copy of that function. Instead, it receives the same function in the memory. So anything you are changing here, you are also changing and modifying the object that you received. To demonstrate this, let's create a new variable. Let's call this person1, and here we will set a single property, which is name, and let's set this to Alice. Now if we call that function change name and we pass our person1, it will receive this person1 here and it will change the name and set it to Bob. And if we console log the person1 after this operation, you can see that the name was altered and it was set to Bob. And why this is important to understand is because if you don't want to alter this person object that you passed to this function, you need to create a copy of that object, and here inside of the function body, before doing this operation, you can copy that object, let's say copy of person, and you can copy that person by doing again destructuring and accessing all of the attributes of this person. And now instead of altering the person name, you can alter the copy of person name, and in that case you will still have the same name on the person1 object that you have here. So this will help you avoid unexpected bugs. When you modify an object referenced by multiple variables, those changes will be visible through all of them. And understanding this can also help you to do efficient memory management. So now you know that primitive types are stored directly, while reference types use memory addresses, and this impacts how your code utilizes the memory in JavaScript. And in the last part of this module, let's talk about the scope in JavaScript. In JavaScript, scope defines the accessibility and lifetime of variables within different parts of your code. So you can think of them as a set of rules that determine where you can see and use these variables. The first type of scope is the global scope in JavaScript. Variables that are declared outside of any function or block have the global scope by default, which means that they are accessible in anywhere in your code. For example, if we define a global variable, let's name this as global variable, and we assign this to anything, let's say this is a global variable, we can access this variable from anywhere in our code. For example, if we have a function, let's call this my function. Here we have access to that global variable. If we console log that variable here, and let's call this function below the declaration, you can see that we have access to that, and we can see the value of that global variable inside of a function. And we also have access to that global variable from the global scope, obviously. If we console log that global variable, we also have access to it from the global scope, and from anywhere. If we also define an if statement and we do some conditional, we also have access to that global variable here and from anywhere in our code. Next, after the global scope, we have the local scope, and variables that are declared within a function have local scope. They are only accessible within that function. Let's create another function, and let's just name this something, function1. Here, if we define another variable, and let's name this to be local variable, and let's assign value local to this, we have access to this local variable from here inside of the function body. If we console log the local variable and we call this function after that, you can see we have access to that variable, but we don't have access to this from outside of this function. If I try to access to that variable from outside of the function, you can see that we are getting an error which says that local variable is not defined, and that's because in the global scope we haven't defined this local variable, and it's only defined in the local scope of this function, and we can access it inside of the function, but we cannot access it outside of that function. And lastly, we have the block scope in JavaScript. Variables that are declared with let or const keywords within a block, and block means within if statements or within for loops or any kinds of braces, have the block scope, and they are only accessible within that specific block. For instance, if we have an if statement, and here we have some condition. For now, let's just say if true, which means that it will be always true. we can define a block scope variable here. So anything that you define here with let or const keywords are block variables. And if we assign some value to this, let's say block variable, you can access to this variable only inside of this if statement. So you cannot access this outside of this statement. If we console log that variable here, you can see that we have access to it. But if we try to do this same console log outside of that if statement, we will get an error saying that block variable is not defined. And one more thing I'd like to mention about the local scope. Let's say you have multiple functions nested together. Here, let's say you have function 2 nested inside of function 1, and you also have function 3, which is nested inside of function 2. Inside of the function 3 body, you can access all of the variables that are defined inside of function 3, which is the local variable 3. And you also have access to all of the variables inside of function 2, which is in this case is local variable 2. And you also have access to the local variable 1, which is inside of the function 1. So from here, you have access to all of the functions that are above this function, but you don't have access to local variable 3, for example, from this function 2. From here, you only have access to local variable 2 and 1. And from the function 1, you only have access to this first variable, and you don't have access to any other variables that are nested inside of this function. And to verify that, we can call the function 3 here and also function 2 here. As you can see, we have the local 3, local 2 and local variables access here. But if we try to access it here inside of the function 2 body, you can see that local variable 3 is not defined. So if you remove this, we have access only to these two variables here. And if we try to do the same in the function 1, you can see that local variable 2 is not defined. So we need to get rid of this. And here we only have access to this first variable. So inner scopes can access variables from outer scopes, but not vice versa, which means that the function can access to global variables and also all of the above functions, and the block can access variables from its enclosing function or global scope. And also variables with the same name can exist in different scopes without conflict. Let's say we have a variable x and it's assigned to 10. We can have a function here which does the sum of some numbers. Here we can create another variable, but we can name this the same. This can be x and this can be equal to 20. Here if we console log that x and we call that function here, you can see that inside of this sum function, the x variable refers to this variable which is assigned to 20. But if we console log that x outside of that function, in this case, this refers to this x variable which is set to 10. And this is called shadowing, where the inner scope variable, which is this x in our case, shadows the outer one within its block. And understanding scope is important because it helps you organize your code by keeping variables contained within their relevant sections. It will also prevent accidental name collisions between variables in different parts of your code. And this is also good for memory management. Variables with limited scope are automatically cleaned up, garbage collected when they are no longer in need. And this will free up memory in your program. Welcome to the DOM section of our JavaScript course, which stands for Document Object Model. In this module, we'll be building this simple quiz app together, and as we go through each lesson, we'll learn new DOM concepts and apply them directly in this app. So this will be a quiz app with multiple choice answers, and you will see the score at the end of the quiz, and you also will see the wrong answers. So you will see your answer and also the correct answer here below. And here is a high-level overview of what we'll be learning in these lessons. First, in this lesson, we will learn what is the document object model and also what are DOM nodes, elements, and attributes. Next, we will learn how we can select elements from the DOM with methods like query selectors or element selectors. And after selecting them, we will learn how we can manipulate the text content inside of these elements and also how we can update the attributes like the class names or styles. And then you'll learn how to handle user events on the screen. And we'll learn how to attach event listeners in our quiz app to listen for events and invoke functions. And we'll learn the common event types like mouse click, mouse over, submit, or key down. And finally, we'll learn how we can create a new DOM element using JavaScript and how we can append this element to other DOM elements. So let's start this module by understanding what is the DOM or document object model. When a web page is loaded, the browser creates a document object model of this page, and this HTML DOM model is constructed as a tree of objects. So the DOM is like a blueprint of the HTML structure that we have in the web page, and it allows JavaScript to access and change content, structure, and styles dynamically. So the document consists of a root element, which is the HTML wrapper element. And then if you remember, inside of the HTML element, we also have the head element and then the body element. And similarly, each of these elements can have children, like the body can have a button child and it can also have a h1 child. So we call these objects as elements in the DOM model. And then inside of each element, you can also have a text content. For example, inside of the h1, you can have JavaScript quiz. Inside of the button, you can have the submit text and so on. And additionally, each element can also have attributes. For example, you can attach an ID to this button, or you can attach a class name or styles, and these are called attributes in the DOM model. And with this object model, JavaScript gets all the power it needs to create dynamic HTML, which means that JavaScript can change all of the HTML elements, attributes, CSS styles, and everything that you see in this DOM model. We can alter everything here with JavaScript. So if we imagine our quiz app, if we want to display questions with multiple choices, we can use the DOM with JavaScript to make those changes in real time without needing to reload this web page. So as I select one of the choices and click submit answer, this page doesn't refresh, and instead we are just altering the elements that we have inside of this DOM. And to follow along, you can download the quiz app starter code in the description below. It will be a zip file, and once you unzip it and open it in your code editor, you will see these three files, and one of them is the index.html, which contains the content of our quiz app. And the structure is pretty basic. We have one container div inside of the body, and then we have this heading tag. Inside of the question container, we will be inserting the question in this paragraph, and we will also insert the choices inside of this div element. Then we have a button to submit the answer, and at the end we have this result div, which as you can see is empty, so this will not show anything until we want to show something inside of this, and we will control that by using JavaScript. And at the bottom you can see we have the JavaScript file attached with a script tag, so if we go inside of that script.js, for now it only contains the quiz data, which is an array of objects, and each of the objects is one of the questions. So for each object we have a question property, which holds the string of the question. Then we have choices, which is an array of choices, and each of the choices is a string. And then we also have the correct answer property, which indicates the index of the correct answer. Which means if the correct answer is 1 here, that is the index of the correct answer in the choices, which is 22. Or here, when we have the correct answer as 0, that is the first element inside of the choices. So download the zip file from the description of this lesson to follow along. And in the next lesson, we'll start by selecting these elements in the JavaScript, and we'll begin building our quiz app. Now that we know the basics of DOM and we have our quiz app starter, let's learn how we can select those elements from the HTML in our JavaScript file. To start, let's run this with a live server. And as you can see, we don't have the choices displayed here. That's because we didn't select these elements on the screen yet and we didn't populate them. So let's learn how we can select them. And basically we need to select all of the elements from here which are empty because we need to insert values inside of these elements. And these are the question paragraph here, the div with choices ID. We will also need this button later to listen for submit events, and also this results div where we will populate the result of the quiz. And to do this, we will use the getElementById method. We kind of saw this already when building our online calculator, but let's come back to this and let's understand how we use this method. So if you remember from the previous lesson, we have the document at the top, which allows us to select those elements in the DOM. And on this document object, we have a method which is called getElementById. And this method accepts only one argument, that is the element ID, which is a string that we are trying to select. And if we have a look at our HTML file, you can see that we have ID attributes on each of these elements. So if we want to select the paragraph, we will just pass this question ID here. And this should select that element. And we also need to store this inside of a variable. And it's common to call this as the name of that element and add element at the end, which indicates that this is a DOM element. Some people also shorten this and call it like question L, but I think having the full name is better, and you're not saving bunch of space anyways by removing this last part, so it's better to have the full name here. And let's console log this element to see if we really selected this element here. If we save this and open the console in the browser, you can see that indeed we have selected this paragraph, which is currently empty. You can see it on the screen, but now we have access to this in our JavaScript file. And this get element by ID is great for selecting single element with a unique ID, but sometimes we need to select elements based on attributes like classes or more complex CSS selectors. The other option that we have is query selector. We also have a query selector method on this document object, and this allows you to select any element using CSS style selectors. For example, you can select elements by their IDs or their classes or a tag name. For example, if you want to select the element that have the ID question, we will specify it like this, just how we will do it in the CSS, but now we are selecting this inside of the JavaScript file. And if we save this, you can see that we have still selected the same paragraph, and this will select the first element that has the question ID, and this allows you to select by other queries as well. For example, we can select by class name. You can see we have a class name container, and that is this div here. We can come back here, and instead of selecting by ID, we can select by a class name container. This should give us the div container which we have in our HTML file. But what if we want to select multiple elements, like all of the elements that have the ID question? In that case, we have another method, and that is called query selector all. And this is useful when you need to select multiple elements. For example, if we save it like this will return us a node list, which will be an array of the elements. And now we can loop through these question elements, and we will have to make these elements instead of element. And this will be multiple elements, and we can use for loops to loop through this and then perform some operations with them. And the last common selector is to get elements by class name. So we have a method for that, get elements by class name. And here, instead of passing an ID, you pass the class name. For example, if we want to select that container, we will just pass the container class name here. And here you can see that we selected the div, which has the class name of a container. And if we open this is the div container that we have in our quiz app. And these are all of the methods that we can use to select elements from the DOM. Now with that you can complete a small exercise. You need to select all of the elements from here, like the paragraph, the div, this button, and also this div. So you can try to select all of these elements and then store them inside of a variable, and otherwise let's do it together. Let's first understand which method we will use. You can see we can select them by class names, by query, or by element ID. And if we have a look at our HTML file, you can see that all of the elements that we need to select have IDs. So in our case, we will use the getElementById method. And here to select the question element, we will pass the question ID. Next, we need to select the choices that we have under the question, which has the ID of choices. So we'll create a new variable. This will be called choicesElement. And again, we will use the same document.getElementById. And here we will select by choicesID. And let's duplicate this 2 more times. The third element will be this button, which is the submit button. And it's also common to call this as submit button, like a shortened version of submit button. But again, I like to keep them as full names, so let's keep it submit button. And here the ID should be submit button. And for the last element, it will be the result div, where we will populate the result of a quiz. And we need to select it by selecting the result ID. And let's also rename the variable to be result element. And before moving any further, it's good to verify that we selected the correct elements. So let's console log all of these elements, like the question element, the choices element, submit button, and also the result element. And let's save this. And you can see that we are getting all of the elements in the console. And for example, if we have made a mistake, like we misspelled the result here, you will see null for one of the elements, which means that it couldn't select the element. And that's how you know that you made a mistake. And then you will come back and check for the IDs here. In this lesson, we'll learn how to manipulate those elements which we selected from the DOM. And let's start by loading these quiz data questions on the screen and also the choices along with it. And let's start with small steps by only rendering the first question on the screen. For that, we need to create a function below here, and let's call that function to be load question. And whenever we call this function, we want the questions to be rendered on the screen here above this submit button. For that, let's select the first element from this quiz data, which will be quiz data 0 index. Let's name this variable to be first question, and this will be equal to quiz data 0, which will be the first question from there. And from here, we need to display the question and also choices on the screen. And if you remember how we do destructurings from object, we can destructure those properties here. But remember, this should be exactly the same as we have them in the object. So the first one will be question, and the second property will be choices. And with that, we selected the question and choices from the quiz data. And now we want to populate this question inside of this question element. If you remember from the index.html file, the question element is this question paragraph. So we basically want to copy this question from here and we want to paste it inside of this paragraph. And if we save this, you see we have this result. We want to have this same result, but by using JavaScript. And to do that from JavaScript, we have also useful properties on those elements. So every element that we selected has also properties that we can access. For example, our question element has a property which is called text content. And this is the content that we have inside of this paragraph. So currently it is empty. And now we want to populate it with the question. And all we have to do is to just assign this to be the question which we get from this quiz data. And we just need to call this function below here. Let's call that load question function. You can see that this text content was populated. And if you right click and inspect this, you can see this is the exact same paragraph. And now we inserted content inside of that. And we just populated the question inside of this paragraph tag. And similar to that, we also need to populate choices inside of the choices element. And we want each of these choices to be a button so that user can click on this button which contains this text and that will be their choice. And once they submit the answer here, we will select that answer from the choices. And to do that, we need to insert button inside of the choices element. And the choices element is this div. If we start from the HTML, we want to have some buttons here that will contain the choices. For example, for this question, we want to have 4, then 22, then some other number. And if we save this, we want to have such buttons, but again, we want to do it by creating them from JavaScript dynamically instead of hard coding them here in the div. First, let's console log the choices to see what we have inside of here. You can see it's an array of choices where each element is the choice that we need to populate inside of the button. That means we need to loop through this first. So we will use the for each method to loop through these choices. And for each choice, we want to perform some operations to insert this inside of the choices div. First, we need to create a button for each choice. And this document object not only allows us to select elements, but it also allows us to create elements. And that is what we will do here. We will use the document.createElement method, and this method accepts the tag of the elements that we want to create. For example, if we want to create a paragraph, we will pass the p tag here, but since we want to create a button, we will pass the button tag here. And let's store this inside of a button variable. And let's log that button to see if we really created a button in our HTML. And indeed, we have 4 buttons which were created as a result of this iteration. Now these buttons are just created, but they are not attached to these elements. As you can see, we have our HTML elements, which is the DOM that we have. And if you try to find them anywhere here, you won't be able to find them. And that's because we are just creating those, but we haven't attached them to any element. So creating those buttons isn't enough. We also need to attach them, and we need to attach them to the choices element, which is the div. For that, we have another useful method on elements. If we access the choices element here, on this we have append child method, and this append child accepts a node, which is an HTML node, and that is this button. For example, we can pass it any HTML node, and this will just append it, meaning that this will insert those buttons inside of that div as children. So we can pass that button here, and if we save it, first, you can also visually see that we have those buttons, but if we go to elements and find the choices element, which is inside of the question container, this is the div that we selected here. And with this line of code, we append those buttons to this choices element. And if you expand the div, you can see that we have 4 buttons which are populated inside of these choices. And as a last thing, we just need to change the text content of this button because currently it is empty. And we'll do it similarly to how we did for the question. We just need to select this button element and we need to assign the text content of this button to be the choice, which is the choice inside of the array. So each of these choices will be one of these choices inside of this choices array. And if we save it, now we have all of the choices populated inside of the buttons, and we also have the question inside of the paragraph. Now that we have loaded our questions along with the choices into our DOM, we can make our app interactive, and in this lesson we will allow users to select each of these choices by clicking on a button, and to do this we need to attach an event listener to each of these choices buttons. So let's go ahead and update our load question function. When we select elements from our JavaScript DOM, we are also getting access to some properties. As you saw, for example, here, we can append children to that element and we can do many things except this one. For example, we can attach event listeners, and in this case, we need to attach an event listener to this button, which is each of these choices here. To do that, we can access the button.addEventListener, which is a method that exists on any of these elements. And the first argument here is the type of the event, which can be click, and it can be key down, or it can be mouse over, and any other events that we have in JavaScript. For now, let's stick with click, because that's what we need here. And the second argument is the listener, which is just a function that will be called whenever this click is handled. Here let's just provide an arrow function and let's console log the event to see if we really called this function. Now if we go back to our JavaScript quiz, if we click on any of these choices, you will see event logged in the console, and if I click on this one, you will see event was called again. And anytime you click on any of these, this function is invoked, and for now it just console logs the event. But this is where we will write a function to handle these clicks and to mark this as selected. For that, let's create a function that will handle this selection, and let's call this select choice because this will be responsible for selecting that choice when we click on this button. And here, instead of calling console log, we need to call this method, which is select choice. Now in this select choice, we need to mark this button as selected, and we can do it by, for example, adding a class name to this and marking the background as blue. And I already prepared a style here for you, and that is this .selected class. So if we apply this .selected, our background color will change to blue, and that will indicate that this button is selected. Here we first need to select the children of our choices element. If we inspect here, you can see the choices is this div, and we need to select the children, which are these buttons. And for that we can access this choices element, and we have a special property for this, which is called children. Let's log this in the console to see if we are selecting the buttons here. If I click on any of these, you can see that we have this in the log, which is the HTML collection of these buttons. And here, for example, we can select the first one, which is at 0 index. And if I save this and we click here, you can see that we selected the first one, which is the value of 4. And now we can access the class list of this element. And we can access it by doing .ClassList, which is providing us the class list of this element. And we can add a class name here. And this class name will be this selected that we have in this tile. So if I write selected here, what we are doing is we are selecting the first item and we are adding a selected class name, which will mark it as blue. Let's save this and try it out. If I click on this first item, you can see the background has been changed to blue, which means that now this is selected. But this is obviously hard-coded. If I try to select the third one, it again selects the first one. That's because we have this 0 index here, which is hard-coded, and this needs to be dynamically applied based on which one we have selected. And to do that, we need to pass that index from here, from this load question. And to be able to access the index here, we will need to convert this for each into a regular for loop so that we can also have the index, and we need to provide it here in the select choice. But actually, there is a second argument for each method. If I try to provide it a second argument, you can see that this is actually the index, which means that we can also access the index inside of a for each loop, which is the second argument. So if I provide the second argument here, this one is the index and this one is the value, which means that this one is 0, 1, 2, 3, and this choice is the 4, 22, and so on. This is the value. Now using this index, we can pass it to this select choice here, and we obviously need to accept it here in this select choice function. And now instead of providing this 0 as hard-coded value, we can provide the index, and this will work dynamically, and we can verify it by clicking on the third element here, for example, or if we click on first element, or whichever one you click on, that one is selected and the background is changed to blue. And one last issue that we need to address here, you can see that whenever we click on this, and then if we click on this one, the last option still remains selected, and we need to clear this after we have selected another option. And to achieve this, before applying this style to the selected element, we can clear this selected class name from all of these buttons. Here we need to loop through these choices element children, and we need to remove this selected class name from all of them before adding this one on the selected item. So first we need to convert this into an array, because right now it is an HTML collection, and we can do that by using the spread operator and spreading this into an array. And by doing this, we can now loop through this by using for each, and for each of the buttons that we have, we will remove the class name. And similar to how we have done it for this one, we can access the class list of each of these buttons, and instead of adding, now we can remove the class name, and we will remove the selected class name from all of these buttons before proceeding to applying this to the selected item. So this will allow users to select an answer and highlight it. And now if we try to select the first element, and now we try to select the third element, you can see that this has been removed from the first item and it's only applied to the third one. And if we select another option, it removes it from the third one and it applies it to the second one. And before wrapping this up, let me show you another event types that you can use. For example, here we used click, but we can also use a mouse over event. And if I save it like this, now whenever you hover your mouse on any of these, it will be automatically selected. This is the mouse over event. You can also have, for example, mouse enter. This is whenever your mouse enters that element, and this will have similar effect as mouse over. And as you can see, we have many types of events here that can happen. For example, you can control the key press or key down. So this is whenever any key was pressed by the user. For example, we can attach an event listener to the document.body, which is the body tag that we have in the index.html. And here we can add event listener. And this time, let's set the type to be key down. And here, if you notice, it says that we can access the event on this listener, and that will tell us which key was pressed and other necessary data. So here we can access that event, and let's just console log it whenever the key was pressed on the keyboard. Now if you go to our website and press on any key, you can see that this event has been called. And here you have a bunch of attributes, and the ones that you will be interested in is the key. For example, I pressed the D key, and this is what we have in the event. And you also have the timestamp of when this key was pressed and so on. And if I click on any other key, you can see that this event listener is being called on any key down, and you are getting the key that was pressed and all the other necessary data. So this is just good to know in case you need to key down events or any other types of events. But for our quiz app, the main event we'll focus on is the click event for selecting an answer and submitting it. And in the next step, we'll use the click event to handle the selection of an answer. Now that users can select an answer, it's time to handle the answer submission. So we need to attach an event listener to handle when the user clicks on this submit button. And we'll also compare their selected answer with the correct answer, and we will increase this score if they have selected the correct answer. To start, we need to define two global variables to keep track of the question and also the score. As you can see, for now, we are just rendering the first question, and we'll need to change this dynamically based on which question is user answering at the moment. So the first global variable will be the current question, which will be the index of the current question that we are keeping track of. And we will start at 0, which will be this first question from here. And the next variable will be keeping track of the score of the user. And they all start at 0, meaning they don't have any score. And once they answer any question properly here, we need to increment this score by 1. And we will use this at the end to display the results to the user. And with that, we are ready to handle the submit answer event. For that, let's define another event listener below here, but before the load question, because we want to have this event listener before we load the questions. And that listener should be on this submit button, which is this submit answer button here. So we will select the submit button. we will add an event listener on this, and again it will be handling click events. And here we need to provide the function that will be called, and we'll call this function now. Let's call that function submit answer, and we need to define this submit answer here below this select choice. Let's define a function, and it is called submit answer, and this won't be accepting any arguments. And here we will define the logic that will handle the submission, but for now let's just console log to see if we are handling this properly. If we click on this submit button, you can see that function has been called. And there is one useful shortcut here when you're handling event listeners. If you are not planning to pass any arguments to this submit answer, instead of writing an arrow function and then the function name and calling it, you can directly write the function name that needs to be called. And this will have exactly the same result. If we click on submit answer, you can see that it still has been called. So we can use that shortcut here because we are not passing any arguments. But for example, here in the load question, we cannot because we are also passing the index, and that's why here we are using the arrow function. So first thing we need to do here is to get the selected answer, which is the one that has been selected here on the screen. And we can easily select it because we know that the selected answer has a class which is selected. So we can find the exact element that has this class name of selected, and we know that it will be only one element. So that's how we can get this button. First, let's define a variable for the selected button, and this will be equal to choices element. And here, instead of finding it by ID, this time we need to find it by the class name. So we can use query selector, for example, and we can query for the item that has the selected class name. And let's see if we selected this properly by logging this in the console. If I select one of these and then I click on submit answer, you can see that we have selected the one which has the class name selected, and now we can access this 22, which is the value of this button. But before doing it, let's just put a small verification here, checking if the selected button exists, because we might have scenarios where user didn't select any of these. And in this case, for example, we don't want to move further. So we want to do nothing until they have selected one of these elements. And in that case, we will just return, which will exit out of this function, and it will force users to select an answer. And now we need to compare this with the answers from the quiz data. For example, here they selected this option. Now we want to compare it with the correct answer and see if the index of that option matches with the correct answer. And if yes, we will increment the score which we defined here. First, we need to get the index of this selected element. Let's define a variable and call it selected index. And here we need to find the index of this button, which if we have a look at the DOM, you can see we have choices and we have 4 elements inside, and these are corresponding to the quiz data. For example, here the first item is at 0, and here as well the first button is at index 0, the second button is at index 1, and so on. And this matches this one, so we will be searching here inside of the choices. And just like how we did it for the select choice, we can loop through its children. But instead of manually looping through this and finding the index, JavaScript provides us a useful method which we can use, and that is called indexOf. And this will search for the index for us instead of us manually doing it. Here we can pass this selected button, and what this will do is it will search for this selected button inside of these children, which is these choices. And whenever it finds a match, which will be here, if we selected the second item, for example, it will return us the index, which will be 1, or if we selected this one, it will be 3. And now we will be able to compare this with the correct answer from the quiz data, and we will increment the score if this matches the index. So here we need to add another conditional, and here we will compare selected index, which is this one. For example, I selected this, then the index is 2, and we will compare this if this equals to quiz data for the current question, and we will access the correct answer here. So we know this for the first one is 1, so that's the first index, and this is the answer that user has provided, and if this matches, then they selected the correct answer. And in that case, we just need to increment the score by 1. And at the end of this, we also want to increment the current question, because now we are starting from 0. We need to increment this to move to the next question, and we will just increment the current question after they submitted an answer. If we save and try it out, for example, if I select the first one and click on submit, and we get an error here saying that we reassigned constant value, And that's because we assigned this as constant. So hopefully you found out this earlier. We need to convert this into a variable, not constant. And same for score, because we will be incrementing this. Now if we save it like this, if we select the third element and click submit, our function is being called, but we don't see the next elements on the screen. And that is because we have this hard-coded value here. We are always showing the first question. Instead, we need to show the current question. And we also need to call this question again after we incremented the current question. We need to call load question again after that operation. And now if we select one of these and click submit, you can see the other options are popping up on the screen. But the choices from the first answer are still here. We need to clear this from the screen, and we can do it in the load question. Here, if you remember, we are populating the choices buttons on the screen, but before doing this operation, we need to clear all of the previous choices that we have from the previous question. And we can do that by accessing the choices element, which is the div that contains these elements. And we need to clear it by using the inner HTML, which is another property that exists on HTML elements. And we just need to set it as empty string. And now if you select an answer and submit it, you will see the next questions, and you can click on one of these and submit. So basically we are clearing the previous questions and we are populating the new ones in this load question. And after that, we are also incrementing the current question to move forward to the next question, and we are loading the questions again. And after user selects all of the questions and they submit the results, we need to show them the results, and that's what we will do in the next lesson. In the last lesson, we allowed users to submit their answer, and we also increment the score if their answer is correct. And now we need to display the score at the end whenever the user completes all of the questions. And for that, we need to define another function which will be responsible to display the results, and we'll call this function as showResult. Before writing the logic of this function, let's first think about when we want to call this function. So whenever all of the questions are submitted and there are no more questions remaining, we want to display the result instead of the choices. And we can determine that in the submit answer. So whenever the user answers the last question and there are no more questions remaining in this quiz data, that's when we want to display the results instead of the next question. And we can determine it easily by adding another condition here. And we can check if the current question index is less than the quiz data length, which will mean that if the current question is 0, for example, and in our quiz data we have 3 questions, it will be less than the quiz data. So we will continue. And in this case, we will call the load question to load the next question with its choices. But if not, if this is not the case, which means that this is equal to the quiz data length, which means that it's the last question. So this is where we will call our function and we will display the results instead of displaying the next question. And now let's write the logic of this function. So let's first identify which container we want to hide. As you can see in our HTML file, we have this div, which is the question container, and it contains the question and choices, which is this part in our website. So whenever we want to display the result, we want to display the result inside of this div. And at the same time, we want to hide this question container because we don't want it to be visible on the screen. For that, we first need to select the element by this ID, which will be the question container. And we'll do that here above the question element. Let's define another element for the question container. And this will be equal to document.getElementById. And the ID of this is question container. And with that, we will select the container div. And here we want to hide it first. There are multiple ways to hide an element in the DOM, but one of the easiest ways is to set the display to none, so we can access the element and then we have a property on it, which is the style. And here we have access to all of the properties that we can set in a CSS file, but we can do it from JavaScript. And here we can, for example, set display and we can set this to equal to none. And we need to do the same for the submit button because we don't want this submit answer to be visible at the result screen. So we will also grab the submit button and we will set the style.display to be none as we have for the question container. And now if you try to answer all of the questions and submit the answers, and the third one is the last question. So here when I click submit answer, we will get into this else block and this show result will be called. and if I click submit, you can see that we hide the question container, which contains the question and choices, and we also hide the submit button. And now we need to populate the result, which is this div here. We need to populate this result with the score, which we have access from this global scope. And we have already selected that div, which has the ID of result, and that is stored inside of the result element variable. So here we can access that result element variable, and we can insert HTML elements by doing inner HTML, which we used before. And for now, we can just display the score. And if we answer to all of the questions and hit submit, you can see that we have the score as 1, which means that we correctly answered to only one question and the other two were wrong. But instead of displaying it like this, we can add styling to it. We can define a variable here like result HTML, and instead of inserting just the score, we can insert HTML elements here. For example, you can insert a paragraph tag and you can add text in front of the score. For example, we can say use scored, and then we can display the score here. And we can close this paragraph tag. And in the style.css, I also added this score class, which will set the font size to be a bit larger and it will reset the margins. So we can apply this class name here. We can set the class for the paragraph tag to be equal to score. And now instead of inserting score here, we can insert the result HTML. And now we will have useScored and the score in front of it. But we can also make this as a percentage, and we can also show the total count of questions that they answered. To convert this to a percentage, we need to multiply this by 100 and then divide it by the count of total questions, which is quizData.length. And we also need to round this, so we will use math.round and we will pass it inside of it here. And let's add the percentage in front of the score and save it. Now you can see that we are displaying the score as a percentage, and as a last thing we can add the score and total questions in front of it. We can say score out of quizData.length. And now you will have you scored the percentage and also the 1 out of 3, which will indicate how many questions they answered correctly. So when the quiz ends, the user will now see their final score displayed in a clear and easy to understand format. But there is one thing missing here. They cannot see the questions which they answered wrong, so they can practice for the next time. So we will also need to display the wrong answers here, and that's what we will do in the next lesson. In addition to showing the final score, we can make our quiz more informative by displaying any incorrect answers on the screen. And this way users can learn from their mistakes and see which questions they got wrong. To be able to display the wrong answers, we first need to add another global variable. We'll need to define an array of wrong answers, and we will be pushing all of the wrong answers inside of this array. So if the user selects an incorrect answer and they click on submit answers, we need to detect that and push that answer inside of these wrong answers. And that will be at the point when user submits an answer. So we need to add that inside of this function. And we already have the conditional for that. As you can see, we have this if statement, which checks if the answer was correct. And if not, we can enter into an else block. And this means that the answer was incorrect. And in this case, we can push that question inside of the wrong answers array. And we can use the push method to push it. And we will add an object inside of it. The first property that we will store is the question, so they can see which question they got wrong. And the question here is the quiz data current question and then dot question. Next, we need to inform them about their answer, which we can call user answer, for example. And here we will give them their answer, which will be quiz data current question. And then we can access the choices from this current question. And their answer was the selected index, which we can provide in the choices. And we also need to keep track of the correct answer so that they know which one was the correct one. We can store another property called correct answer, and we can access the correct answer by accessing the quiz data for current question. And then we have this correct answer, which indicates the index of the correct answer. And this is how we will add all of the wrong answers inside of that array. And we need to use this array at the end when we display the result. And we also need to display the wrong answers here below this score. So here we first need to add a conditional, and we need to check if the wrong answers dot length is greater than 0, which will mean that they have answers that were wrong. Because if they don't have any wrong answers, we don't want to display this on the screen, and otherwise we will display all of the wrong answers. So we can convert this result HTML into a variable because right now it is a constant. And now we can push more things inside of that result HTML. First, let's add a heading inside of this result HTML by adding an h3 tag. And here we will indicate wrong answers, which means that we will be displaying the wrong answers below this. And here we will loop through the wrong answers by using the for each again. Here we will get the wrong answer and we need to push this inside of the result HTML. And here this just needs to be result HTML, not result element. Result element is the element that we selected from the DOM. Here we need to add some more things to that result HTML. For each of the wrong answers, let's add a list item. And inside of this list item, we will have paragraphs. The first paragraph will indicate the question, which will be the question that we have inside of this answer. And we can access it by doing answer.question, which is the question that we stored here. And next we need to access this user answer, which is the wrong answer. So let's close this paragraph, and below this we'll add another paragraph. We'll say your answer, and here let's add a span element, and inside of this span element we'll display the answer.userAnswer. And we need to close the span element, and we also need to close the paragraph element. And let's copy this line one more time, and here we will display the correct answer. So we'll say correct answer. And from the answer object, we will select the correct answer, which is stored under correct answer property. Now we just need to wrap these list items inside of a UL item. For that, we need to push a UL element inside of this result HTML. First, we will push the opening UL tag. And then after this for each, we will push the closing UL tag like this. And now when the user completes this quiz, they will have the score, and below that they will have the wrong answers if the wrong answers length is greater than 0, meaning if they have wrong answers in the quiz. Let's try it in our quiz app. And as you can see, we are getting the score in percentage and then the correct answers and total answers. And we are also getting the wrong answers here. Here the user can see the question which they answered incorrectly. They can see their answer and they also can see the correct answer. Now the correct answer indicates the index of the correct answer, which is not very useful for users. So we need to modify this to display the value instead of the index. And we will do it here when we push it inside of the wrong answers. Instead of pushing this index, we need to push the value. So let's cut this from here. Let's access the quiz data of the current question. And then we have access to the choices from here. And from the choices, we will select the choice which has this index. So now we are accessing the value instead of accessing the index. And with that, you can see that we are displaying the value of the correct answer, not the index. And as a last small thing, let's just mark the wrong answer in red and the correct answer in green. And we can do it again by using the styles from our style CSS. We already have styles for the correct answer and for the wrong answer. And we just need to add these class names to the li items that we have here. So here we have this span which indicates the user answer, and obviously that is the wrong answer. So we can add a class name to this and we can add the wrong class name. And for the correct answer, we will add another class name and this will be correct, and this matches with the styles that we have here. And with this we finalized the quiz app, so let's just see how it works. We select the answers and then we select the last answer and submit. Here we can see the score and we can see the total number of questions and also the correct answers. And we also see the wrong answers, and the wrong ones are highlighted with red and the correct ones are highlighted in green. And this quiz app works dynamically, which means that we don't have to have 3 questions here. You can add as many questions below this as you want. And the code here works dynamically in a way that you can add as many questions as you want, and it will not break the application. And this will work for any amount of quiz questions. And that was it for the basics of JavaScript. But if you're ready to dive deeper into more advanced topics like debugging techniques, error handling, or asynchronous JavaScript and how to use API calls to build real-world applications, then check out the link in the description for the full course. I'll see you inside.